But for the plural,
No,
it's come state.
Okay, come state.
Come state.
You can also say, okay, come state.
Just come state? Oops. Just come state?
Yeah, come,
Okay.
come state.
Okay.
Okay, super cool. So we're back for the morning announcements, and you know a little ritual. Oh. And you know what's up next? This is. Oh well, you're improving. Okay, but this is the first part of a little exercise. So let's improve. Let's learn something while we're here in beautiful Rimini. So it's buongiorno. Is that good? I have an expert, one of the room managers.
Come state?
So. No, louder again.
Louder.
So, buongiorno, come state? Okay, thank you very much. Thank you. Yeah, give a little hand for the room manager. Okay, our little ritual includes no food and drinks in the room. Please be a responsible adult and clean after yourself. Also, I'm not aware of any schedule changes so far, but please check the app. We'll also give you a notification in case something changes. And who wants to go to Daniela's training this afternoon? Like this morning, sorry? Who? Anyone? Nobody? Raise your hands. Have you downloaded everything already? Oh, you should do now, because there's stuff to download. So prepare for the trainings. Check on the training site, like just on the website, the trainers put the links there, what you have to download up front. Don't start downloading when a training will start. You will just steal everyone's time. There's a PSF meeting in the afternoon. The PSF, if you don't know, that's the Python Software Foundation. It's located in the States. It's basically protecting the Python language and the trademark. And there's a meeting in the room, and if you want to meet one of these great people, like Eva, go there, talk to them, it's open. Also, I told you about the Coconut social event, and we said we have 50 tickets left. Those 50 tickets are actually gone, but good news, we got extra 50 tickets, and there's probably like 30 left now. So if you want to go to the Coconut social event tomorrow, buy your tickets online. There will be 30 left. Most likely we won't up that. So buy it online, you can pick up your ribbon downstairs, but these will be most likely the final ones. So order now. Yeah, and then enjoy the conference. Thank you very much.
Using this one and perhaps this one. Two.
Oh. Looks promising, yes.
Super.
All right, so now I want to welcome you, our next keynote speaker. It's Catherine Jamour. First time I saw Catherine, it was actually online on videos recorded at PyCon US, where she was talking about web scraping and data mangling, and I really loved her talks. Finally, we got to know each other actually in Bilbao in 2015, and as you know, like, she's an author. She wrote a book on data mangling on O'Reilly. She does video courses. He's one of the organizers of PyData Berlin. She's a very active member of our community, and now she's going to talk about ethics and data. Oh no, sorry, you're basically also like you're European basically. No? She was born in LA, but you're in Berlin since 3 years?
Yeah, about 3.5.
3.5. So, and Yeah, so, and today she's going to talk about ethics and ethics and data. So this is not a technical keynote, it's more an ethics keynote. So I want to give you a very warm welcome to Catherine. And
Thank you for being here. I know there was quite a fun social event last night, so I appreciate you getting up early and joining us. And I want to thank all of the organizing committee for organizing such a great conference and also inviting me to be here. Today I'm going to talk about a topic that is quite controversial in some circles. Now, ethics might be something that you learned about in school. It might be something that you even debate on the world stage or when you talk about politics with your friends. But it's not often that in the work that we do every day, we get into ethical conversations. But I wonder if it should be. I myself work as a data scientist, and I myself face these types of ethical conversations often when I'm building models or when I'm thinking about how we use data. And because of this, I think that perhaps us, even as a larger computing field, even if you don't work with data, perhaps this is something that we should be talking about. So what we'll do today is I'm going to take you through some of the history of computing with an ethical focus. So we're going to take a look at important moments in computing history and some of the ethical reasoning behind them. To begin with, we will start with an IBM advertisement from 1960.
This is where America's peace of mind begins. Around-the-clock radar electronic eyes watch the skies and report what they see to SAGE, defense system of the United States Air Force. Here is a SAGE sensor on it.
Oops, sorry. Don't know how to make those go away. Sorry. Yeah. All right, we'll actually move forward because in the interest of time and in the interest of all of your time, what this is an advertisement for and what it goes on to explain is the SAGE system. And this system is a satellite air system. And what it is supposedly doing is tracking all of the aircraft over the United States. And its goal is to have these people, these intelligence workers, to be able to click on a screen at these unknown aircrafts and then fire missiles at them and destroy them midair, therefore protecting the United States from quote-unquote Soviet attack. This was a system that was designed by a lot of intelligent computer scientists, a lot of people that were building IBM's best computers at the time in the late 50s and early 60s. And when I saw this advertisement, I mean, it's quite over the top. I will have to post it later so you can look at it yourself. But I wondered what the computer scientists who were working on this machine thought. I wonder if perhaps they were at all concerned ethically about their creation. And in testing, actually, this SAGE system was wholly ineffective. In one test called Operation Sky Shield, it would have only neutralized 25% of targets, leaving 75% of missiles incoming and to whatever devastation they were able to make. And so I wonder if when they saw this advertisement and it's made to seem like, you're completely safe and secure because we have a computer and the computer will take care of it all. I wonder what the computer scientists actually thought, the computer engineers who were building this system. And I wonder if they were concerned with how it was marketed and if they were concerned about failure. So this is a constant problem in computing. Computing has been touched by the military, has been touched by state intelligence systems in a lot of ways throughout history. And the first computer scientist and mathematician we'll look at is Norbert Wiener. And Norbert Wiener was a famous statistician in his time, and he worked with neurologists and other mathematicians to help discover some of the ways that our brain sends electricity. So this was when we were first discovering how electrical signals travel through the brain, and when we were first discovering neural networks. And he also did some statistics for the military. In fact, his work went on to contribute to the minimal mean squared estimator, which essentially allows us to estimate, he used it for flight paths for missile defense. So he himself worked with the military. He himself probably had his own ethical qualms. But his seminal work is a book called Cybernetics, and he was actually one of the first to coin this term. This is this idea of using computers as an aid to help us make decisions. And in Cybernetics, he has a quote that I think is important to share today. I'll read a slightly longer version than we have here. I have said that this new development, computers, has unbounded possibilities for good and for evil. It gives the human race a new and most effective collection of mechanical slaves to perform its labor. Such mechanical labor has most of the economic properties of slave labor, although, unlike slave labor, it does not involve the direct demoralizing effects of human cruelty. However, any labor that accepts the conditions of competition with slave labor accepts the conditions of slave labor and is essentially slave labor. The key word of this statement is competition. It may very well be a good thing for humanity to have the machine remove from it the need of menial and disagreeable tasks, or it may not. I do not know. When I read this quote and I realized that it was written in 1948, I was a bit surprised that I don't feel like we've moved much further along in the conversation. I feel like this quote could be shared in an article today, in a blog post today, in any type of news today as we debate automation and jobs. The people in our field, we work to automate tasks away. Sometimes we work on systems that will entirely replace an industry. And therefore, are we then responsible for the degrading of lives that happens when that occurs? Perhaps it's better that nobody has to be a factory worker, or that nobody has to drive a taxi if they don't want to, or be a truck driver, and so forth. But what does it mean? Is it the tyranny of the few? Is it perhaps those of us that can automate away things and the societies that can afford to automate away things versus those that perhaps can't? And if those other societies or if other nations can't keep up, does this mean that they're essentially competing against these robots, against this, as he so calls, slave labor? The next mathematician that we'll look at, and great computer scientist, is Joseph Weizenbaum. Now, Weizenbaum was essentially a contemporary. He was a German Jew, and he was born in Berlin. His family escaped Nazi persecution by emigrating to the United States, and he grew up and was educated primarily there. He became a professor at MIT in the 1960s, and you might know of his work because he built ELIZABot. So for those of you familiar with natural language processing, or perhaps you've just heard about it, the ELIZABot was probably the first chatbot, and it used natural language patterns to essentially mimic human speech and act as a therapist. Now, Weizenbaum was also famous in his own right for some other inventions that he did. In fact, this is a photo of him at Die Zeit and in 1965, and he's demonstrating remote login to his MIT machine. Weizenbaum came to become quite active politically within his time. And he actively worked to challenge those around him on these ethical and political concerns that he had. I think he felt it especially important, given his family's history, to talk about ethics in computing and what he saw around him. And he began to question whether AI and computer science were a force of good in the world. This is a quote from an interview in an MIT publication in 1985, where I feel like he was particularly candid about his feelings about computing. I'll again read a longer quote. I think the computer has, from the beginning, been a fundamentally conservative force. It has made possible the saving of institutions pretty much as they were, which otherwise might have had to be changed. For example, banking. Superficially, it looks as if banking has been revolutionized by the computer, but only very superficially. Consider that, say, 20, 25 years ago, the banks were faced with the fact that the population was growing at a very rapid rate. Many more checks would be written than before. Their response was to bring in the computer. By the way, I helped design the first computer banking system in the United States for the Bank of America 25 years ago. Now, if it had not been for the computer, if the computer had not been invented, what would the banks have had to do? They might have had to decentralize, or they might have to regionalize in some way. In other words, it might have been necessary to introduce a social invention, not just a technical invention. And this quote for me brought me pause, as somebody that aims to make unmanageable tasks manageable. I aim to make data clean and accessible, to use large and disparate data sets to make inferences or determine some sort of meaning or signal. Am I helping consolidate power? By doing the job with maybe 30 lines and a scikit-learn import, by doing the job that perhaps would be very untenable, take quite a long time, or maybe even impossible, am I therefore helping consolidate this power? Am I using technology to thwart social progress? I don't know the answer to this, but these are the types of questions I'd love to hear your feedback on. Moving on throughout history, we have Ole Johan Dahl and Christian Nygaard. They're essentially the fathers of object-oriented programming, so we have them to thank. Simula 1 and Simula 67, the languages that they developed, were computer simulation languages. They were used to simulate physics in a military laboratory. And Christian Nygaard, here on the right, was a staunch leftist and activist throughout his entire life. In fact, he eventually identified as a socialist. In his belief system, he, of course, believed in supporting workers' rights, and so when he was approached by the Norwegian Iron and Metal Workers Union to help them build a system so that their jobs would not be automated away and instead they would learn computing skills, he jumped at the opportunity. And he was able to work with them and build what many people think is the first example of participatory design, one which the active participants or users or workers are able to help make the design process and able to help determine what the system looks like. And he essentially helped them build an operations research type of scheduler and backlog organizer for the union. He was also quite famous for walking away from military work. In 1960, he quit his job at the Defense Research in Norway and took several of his teammates with him. He often joked that because of that, he had the most funding request rejections out of any person in Norway. He gave a speech at the IRIS conference, which is a group of Scandinavian researchers that meet. And I'll read a slightly longer quote from it. "You need a self-defense against yourself and the temptations to choose a comfortable but wrong way out in critical situations. But compromises may be necessary. The greatest danger, then, is not the acceptance of a dubious compromise, but in not being cynical and honest about it. Your mental processes will try to justify your actions to yourself, making the compromise the desired solution. And you will change yourself if you're not honest and astute. Bo Dahlbom asked me to talk about the Iron and Metal Project. Why? Many people don't know about it properly, he said. And some have forgotten those aspects that ought to disturb them as their environment pushes them slowly to the right. Perhaps I should ask some questions to those in the audience who believe that they have been influenced by the project and its successors. Has anyone resented the content of your work recently? If not, what is your excuse? Have you had any real conflict in your research activities lately? Or does such conflict only belong to your now romanticized, glorious, radical past? Will your recent research, to any extent, increase the power to influence their own fate for people with whom you feel solidarity? He went on to quip that he's joking a bit, but I think the message remains clear. If we're building systems, tools, algorithms, and so forth, if we're building these and they actively work against our politics, against our ethics, against our morality, however it is you choose to make valuable decisions in your life, if we do that, why are we doing that? And if we choose instead to build tools and systems that we believe support our politics, that we believe support our ethics, and we distribute them, can we be then a form of justice? Can we therefore spread, instead of spreading, let's say, something we don't believe in, can we therefore become a way to spread something that we do believe in? Or, as he suggests, are we just constantly perhaps making compromises? And do we need to be very honest with ourselves about the compromises that we are making? Andrei Urshov is a prominent figure in Soviet-era computer science and cybernetics. He worked on numerous inventions along the same time, working in parallel and often collaborating with several computer scientists in the United States and the UK. He's actually famous for likely writing the first optimizing compiler for a language that's more complex than Fortran. He wrote this for the alpha language that he worked on. And he was a really big proponent of education. In fact, he's probably the first computer scientist to talk about computer literacy. He built several schools during his time. He appropriated funding for them. And this, for example, is a photo at the USSR Academy of Sciences during a summer school for young programmers. His belief in teaching and in learning, and that being an important part of computer science, is really espoused in his speech titled Aesthetics and the Human Factor in Programming, which he gave at a 1972 computer conference in the United States. I'll read the full quote, of which only a part is shown here. In past ages, the ability to read and write was considered a rare, God-given talent, gift. The destiny of a limited group of the specially chosen. In the present age of general literacy, we perceive reading to be a universally attainable accomplishment, but we are tempted to single out a new elite group who become arbiters between the lay generality of mankind and the arcane informational model of the world hidden in the machine. Is it not, however, the highest aesthetic idea of our profession to make the art of programming public property, and thereby to submerge our elite exclusiveness within a mature mankind? Indeed, I feel like Urshov approaches these ethical problems slightly differently than some of his Western contemporaries. His idea is not, do we hold some power that we should then further hone for good or for evil? His point is, should we even hold this power at all? Should everyone learn to code? Should everyone learn how a computer works literally on the inside, not just how to turn it on and off? And if not, does our own understanding of computers, does our own ability to code, does, for example, the data scientists in the room, our understanding of statistics and machine learning models, does this give us some special power or privilege? And if it does give us a power or privilege, are we an elite? And what does being part of an elite mean? Does it mean we have a responsibility? Does it mean that we have to do things differently? Moving on to the networking era, which is always fun, right? We all love the internet. Here you can see the employees at BBN, which is Bolt, Beranek, and Newman, a Cambridge research firm. And BBN won a contract with the Advanced Research Projects Agency, otherwise known as ARPA. And their project was to build the first computer network in the United States. They're seen here in 1969 along with their interface messaging processor machine, which is essentially the first router. And in case you don't know, this is the same group that started to create the protocols and the standards that we use in today's internet. There's a bunch of amazing engineers and architects that I could talk about in this photo, but I'm going to focus on two of them. Here in blue, I have Severo Ornstein, and in yellow, I have Bob Kahn. Why just talk about the two of them? Well, first and foremost, because they went on to have longer careers and do quite a lot of work after ARPANET, but secondly, because they were very outspoken in their political and ethical beliefs, and they went in quite different directions. So I think it's perhaps a good case study to explore the life of a computer scientist. We'll focus on Bob Kahn first. Bob Kahn worked on networks and essentially networking protocols. He, along with Vincent Cerf, was able to create the TCP and IP protocols and standards, which are mainly unchanged today, which is a pretty amazing feat. He's essentially a networking genius. He went on to build very large networks for the US military at DARPA, and then after that he went to IPTO, which is the Information Processing Techniques Office. Then he heard about this new project brewing in Japan called the 5th Generation Computer Project. And this idea was, how can we create true AI thinking machines? How can we create these decision support systems that we might be able to use? At that time, he then pitched the idea of the Strategic Computing Initiative, of which this is one of the plans. So for the Strategic Computing Initiative, you have, as you can see at the bottom, all of the infrastructure. These are the networks that Bob Kahn loved. This is something that he loves to work on. He was able to get quite a lot of funding to just build networks and come up with new networking concepts. On top of that, they would then try to build some chips, some different hardware designs, and eventually working to natural language processing and speech and vision recognition and so forth. On top of those technologies, they would build autonomous systems, pilots associates, and battle management. And this was all to, and I quote, develop a broad base of machine intelligence technology to increase our national security and economic strength. So what does this mean? I mean, when I first saw this diagram, I said, well, perhaps Bob Kahn didn't even know about how his networks would be used. Maybe ethically for him, he just really wanted to work on networks. And I can understand and appreciate that. And then I found a quote from around this era of Bob Kahn. And it states, "The nation that dominates this information processing field will possess the keys to world leadership in the 21st century." As I began to read more of his writing during the time and writings of his peers at SCI, for example, Lynn Conway, who is a prominent computer scientist in her own right, it was clear that they were very well aware of how their programming would be used. In fact, it's rumored that the chart that we saw in the last slide, that Bob Kahn himself designed that pyramid. So it's clear that he knew he was building weapons. What I wonder is, what does it mean when we have to take military funding, or let's say corporate funding of corporations maybe we don't agree with, to do our work? Does this make us ethically culpable in what the greater process is? And if it does make us ethically culpable, if something goes wrong, let's say civilians are bombed and so forth, does that make you as the computer scientist or as the data scientist or the machine learning expert, does it also mean that you are culpable? And if you aren't culpable, then who is? Going back to Bob Kahn's peer, Severo Ornstein, he was a co-worker, again, and a peer at ARPANET. And here we see him with Laura Golt, who was a computer scientist and activist as well. Severo's work at ARPANET was as lead hardware expert. So he built most of the hardware for the first router and also did some of the software programming. He later went on to join Xerox PARC, and he worked on the Dorado, which was the fastest processor at the time and operating system. So around the same time that Bob Kahn was petitioning the government for millions of dollars to build weapons, Several Ornstein and Laura Gold were starting another initiative. And this was for a group called Computer Professionals for Social Responsibility. This is one of the patches that the Computer Professionals for Social Responsibility gave out at a joint AI conference, most likely the one in Los Angeles in 1985. And some older folks in the room, or perhaps some that know a little bit of Americana history, this is a play on a famous Cold War era advertisement, if you will. It was a public service announcement that came on, and it would say, "It's 11 p.m. Do you know where your children are?" And its goal was to enforce curfew and to make sure that all the young people were inside at night in case of danger. Now, this play on it is, "It's 11 p.m. Do you know what your expert system just inferred?" And we see the telltale mushroom cloud of an atomic bomb. And these are the same expert systems that Bob Kahn himself was trying to build. I mean, they never really came to much, right? At that time, it was very quickly before what we all know now as AI winter. And these expert systems were never much more than large statistical models. But the fear at the time was that they would be treated as experts, was that if the system itself said, okay, we're under attack, it's time to launch the nukes, that is something that would actually happen and that a human would go about doing it based on this expert system. That was a massive concern for CPSR, the Computer Professionals for Social Responsibility. Now, CPSR was around actually until 2013, and they gave out fairly regular awards, actually named Novotvina, and highlighting people in the field who were working on social responsibility issues as computer professionals. It's a pretty amazing list. We've actually covered some of the people on the list, but it goes on to talk about whistleblowers and other people who really worked actively to act as an ethical agent. But I think what we can really take away from CPSR, or what I took away from CPSR, is that it was starting this type of activist conversation amongst computer professionals. And it was asking, what can we do as people who are concerned about the world, as people who are concerned about social responsibility? How can we help? How can we be a part of change or a part of something that we believe brings justice to the world? And I think that it's quite sad when you read about the history of CPSR that around the time of the personal computing revolution in the mid to late 80s and early 90s, they saw their numbers dwindle. And I think one of the problems of this is computing went from being a social experience in the computer lab, working with your peers, chatting probably a lot about these types of issues and theories. It became a personal and a lone experience. This was also the time that is often tracked to the gender disparity within our field. That's often tracked that the advertisements were all of a sudden, be a gamer, it's really cool for boys to have computers. And so I feel like this was perhaps not intentionally, but unfortunately, one of the fatalities of that era was this conversation about computer professionals for social responsibility. But CPSR was not the only ones fighting for more professionalism in the field or fighting for us to be having these conversations. You might know of Karen Spock-Jones. She's quite famous. She's a statistician as well as a natural language processing expert. And she worked at the Cambridge Language Research Unit on a variety of NLP research. Primarily, her first forays, I guess, are into looking at inferring meaning from thesauri definitions in text. You might have also heard of TF-IDF, term frequency, inverse document frequency. It's a popular way to extract important words or phrases from a text when you have a larger corpus. She wrote the paper that defined the IDF portion of the equation. So she's pretty important when it comes to natural language processing. But that's not her only contribution. Spock Jones was an outspoken critic of the gender disparities within our field. She also was quite a critic of not having some sort of professional code. She thought that the growing importance of computers in people's lives meant that we had more and more influence, and she was concerned that we didn't have any type of licensing, board, review, that we didn't necessarily have any standards for our own code, our own actions. I'll again read a slightly longer quote. I certainly think that professionalism is very important. To be a proper professional, you need to think about the context and motivation and justifications of what you're doing. You don't need a fundamental philosophical discussion every time you put your finger on the keyboard. But as computing is spreading so far into people's lives, you need to think about these things. I've always felt that once you see how important computing is for life, you can't just leave it as a blank box and assume that somebody reasonably competent and relatively benign will do something right with it. Her quote again evokes this idea: who is responsible? If I build a program or write a script or build a model that does something unethical or that can be used unethically, am I responsible for when somebody does that? If I'm not responsible, who is? As especially machine learning and numerous other fields that we work in, as they touch more and more lives, as they're used even by legal experts, or by the police, or by state intelligence, or by doctors, are we not also beholden to these same licenses, these same ethics that these fields have? Now, I'm not necessarily saying we need to have a licensing or we need to have a particular code, but if we have no standards, if we have no way to review one another's work and to think about whether we're following in ethical principles or whether we're helping or hurting lives, then we don't even have a starting place for these conversations on professionalism. And if we're not willing to take on the burden of thinking about these things, then does the burden actually go away, or are we just ignoring it? Finally, we reach some of the outspoken leaders of today's AI in today's era. This is Joanna Bryson. She is a professor of computer science who speaks on AI and natural intelligence at the University of Bath. And she's been working on the field of AI ethics since the 90s. She is a prolific writer and she's published all the time. She has a paper over this past year on the ethics of looking at word vectors and different gender disparity within them. But she also has some older works. For example, her paper, Just Another Artifact, Ethics and the Empirical Experience of AI, articulates this problem of humans over-identifying with artificial intelligence. She essentially says that instead of treating it like a book or a reference, we treat AI as a human actor, as another intelligent human being with reason and common sense and so forth. And she states that this is quite dangerous. If we start treating AI as more expert than ourselves, if we start treating it as the sole singular expert in the room, then what happens when it makes a mistake? So she's been quite outspoken on these issues. On one of her longer posts, she articulates some of her well-thought-out opinions on how we use data. I'll read again from a longer quote. As we in the computational computer social sciences learn more and more, our models of human behavior get better and better. As our models improve, we need less and less data about any particular individual to predict what they're going to do. So just practicing good data hygiene is not enough, even if that was a skill that we could teach everyone. My professional opinion is that there's no going back on this. But that isn't to say that society is doomed. Think of it this way. We all know that the police, the military, even most of our neighbors could get into our house if they wanted to, but we don't expect them to do that. And generally speaking, if anyone does get into our house, we are able to prosecute them legally and claim any damages back from insurance. I think our personal data should be like our houses. First of all, we shouldn't be seen as selling our own data, just leasing it for a particular purpose. This is the model software companies already use for their products. We should just apply the same legal reasoning to we humans. Then, if we have any reason to suspect our data has been used in a way we didn't approve, we should be able to prosecute. That is, the applications of our data should be subject to regulations that protect ordinary citizens from the intrusions of governments, corporations, and even friends. What Joanna Bryson is asking of us here is to actually be better than the current laws. Now, we could get into some debates about the new EU privacy regulations and the fact that, yes, indeed, it has some ways that I can control my own personal data and I can request information about how my data is used. But those are clearly not global, and they have yet to be determined in the courts how they'll be enforced. What she's asking us to do is to treat people's data like their property. Would you buy and sell another person's property without them knowing it? And if not, why do we do this with customer data? Would you collect pieces of another person's property without properly informing them in plain English so that they can understand what they're agreeing to? And if not, why do we do it in our terms and conditions? And a particular concern of mine regarding security, would you take your friend's laptop or computer or books or whatever it is that they have, and would you leave it on a public table outside for everybody to walk by and perhaps look at? And if not, then why are you leaving your databases with protected information or your models with protected information on the public internet? Debating ethics at work is nothing new. My great-grandmother was a pretty amazing woman. Here's her. Her name was Adele Matilda Rich. Her on the left is her growing up in New York City, and she used to tell me really fun stories in the 20s and 30s of growing up in New York City. And her on the right is her with a very young version of me. Now, Madele, as I used to call her, was amazing. She has a lot of good memories that I have in my mind. But the reason why I bring her up is the fact that she worked as a secretary on the Manhattan Project. The Manhattan Project was the project, in case you don't know the code words, for the nuclear bomb in the United States. And she worked as a secretary. She used to tell me fun stories that she did something important for the war and that she had to burn her notebooks and so forth. And I just thought it was a fun story until I got older. She died when I was a child, so I was never able to have these types of conversations with her. But I did talk with my mother, who I know had several conversations. And she said that Madele at first didn't know exactly what she was working on, but slowly put the pieces together over time, and then of course when the bombs were dropped, she was quite aware. And I asked my mom, did she ever regret it? Did she ever stay up at night wondering if what she did was right or wrong? And my mom said that she thought that Madele felt like many of her generation that she was helping the good guys, and that any deaths that were created by the atomic bombs dropped were just small casualties in a larger war. I wonder if I could go back and ask her if we could have a longer conversation about this. But it also makes me wonder if my own privilege now, something that she worked so hard to do, she worked to help make sure our family could survive through the war and the Great Depression, and she made it so that my mom could be the first one to go to college. And my mom going to college meant that I was able to get a computer and that I was able to go pursue computer science. So maybe it is wrong of me to question something like that. Perhaps she was not in a position to make a decision between ethics and feeding her family. And perhaps it is rather ignorant of me to even ask that question. But I also wonder if it is not a right for all of us to have rewarding work that's both challenging mentally, financially rewarding, and also ethically something that we can support. So I challenge us as a community, as data scientists, web developers, if you work on MicroPython, Core Python, Jython, whatever it is that you do, Internet of Things, I challenge us to start having these possibly more difficult conversations. I challenge us to start thinking about who is responsible and how we can hold one another accountable. Now, you might not work on anything that touches ethics, but perhaps you do, or perhaps a coworker does, or a friend, or a colleague, or somebody you meet at this conference, perhaps a future you, or a past you. I know in my career, I've been definitely asked to do unethical things. And I've been asked to lie, to make charts look different, to make data look different for the greater good, right? For extra funding, for whatever it is that the goal of the company or the product is. So I've had to have some of my own ethical decisions. I think that hopefully what we've heard today and what we've shared today can start to be a ground for a communal conversation. I know that in a community like this one, we have values. For example, I feel like as a Python community, we value diversity. I feel that we value free software and open source, and I'm very proud of that. I also feel welcome and supported today, just the same as my first Python conference in 2010. So we have these shared beliefs and these shared values already. But perhaps we don't have a larger understanding of how they relate to ethics in computing as a whole, or how they could inform a communal ethic or communal principles, codes of conduct, ideas that we share with one another and conversations that we have openly. Now, it may not be that we come to some communal agreement, but just the idea of sharing our stories openly, sharing stories like these from around the world openly that tell us a little bit about the history, the ideas, and these deep questions and dilemmas that we have. Perhaps that is a way to start being a better force in the world. We data scientists, programmers, Pythonistas, computer and software engineers, we do have this cultural and ethical history. I hope that is shown. This is only just a few of what I was able to find in my research. I want us to share these stories, and I want to hear your stories and have you share your stories as well of these ethical dilemmas that we face and the decisions that we make around them. And I truly, truly believe that in doing so, we are more. That when we have these conversations together, we're actually contributing to a greater good. Perhaps by having all of these conversations and working together, we can make sure that AI, machine learning, natural language processing, and Python have a bright future in justice. And that that's something that we can be really proud of. And I know that I want to be a part of that, and I hope that you do too. Thank you so much for being here, and I hope to continue this conversation throughout the conference.
Everybody's really quiet because there's a lot of thinking going on in the room, but we have time for questions. So who has questions or comments? And if you're able, it would be nice if you count down. Try to speak up.
So I have a question about what you said about banks, that if there was no computers, they would actually fall different. But thanks to the computers, we have alternative ways right now, like PayPal and most recently cryptocurrencies, which basically allows us to operate without banks. So what do you think about this?
Yeah, so I definitely think I shared some folks today throughout history, and there was a few that touched a little bit on this, but I feel like this is definitely something more of our generation, our era. The idea of using kind of some of this technology to subvert the norm, right? To actually actively work against corporate influence on our life or government influence on our lives. So I think that there's a lot of ways that technology can be used to kind of actively work against some of these ideas. I completely agree, and I think that that's a really important conversation that unfortunately didn't quite fit in this talk, but I think that's really important to share and think about. And this is kind of this idea of us creating technologies that actively support what we believe in, and then as we spread them in the world, that hopefully makes more things possible. Like I look at teams like the Signal team and what they're working on, and I think it's really great. There's some amazing work out there, and perhaps you work on those things as well, and these are really interesting conversations to me and things that we should also be highlighting, right? Thank you.
Hi, thank you for the amazing talk. I would like to ask you a question about automatization, especially if you see difference between what will happen probably with this machine learning revolution in some sense, and something like the Industrial Revolution or what happened in China. Because, I mean, the advantage that I see, all those other things that happened in the past, is that in fact they lifted a lot of people from poverty, even though it was not a great process in some sense. That was the main advantage. What one should always say when you talk about, automatization machine, it has also a human side, which was, helping people. What do you think there is some differences between what will happen and that had already happened, and why this should raise some different question regarding ethics?
So sorry, the question exactly is about how the computer revolution is different than revolutions before it? And sorry, more.
And the question is, how do you think ethically this is different in some sense? What we should think about? Is this just automatization on a larger scale?
Yeah.
Or is something inherently different?
Yeah, I wonder about that because, clearly the Industrial Revolution was, and other previous revolutions, for example, the printing press and so forth, created their own ethics and their own issues. What I wonder about with computers is, like as we've seen with Moore's Law and then also with the new post-AI winter, we're seeing like quite a lot of progress in a short amount of time. I don't know if that's the same amount of progress. I obviously wasn't alive then, and I'm no expert on previous revolutions. I'm not even an expert on this revolution. So I don't exactly know, but I wonder if the pace and perhaps the expanse is slightly more impactful now. That maybe because of the internet and because of the advances that we've made in computing, perhaps we have like a more quick impact on people's lives. I don't know if this is true, but sometimes I think that perhaps this might be the case. But I would be curious to hear more of your thoughts on that topic as well.
Great talk, really great. I was thinking about the ethical side of what we do on daily basis is really important, but my concern is more, for example, the people who started investigating the atoms and their subparticles many years ago, they had no idea that this will lead to the Manhattan Project. So do you have any advices how we can try to predict the future implications of our work and how the ethical result 50 or 100 years from now?
This is something where if I had an answer for you, I would be telling it to the world from the rooftops. And I don't know, I think perhaps we need to, I echo that concern. I don't know what things that I work on today and things that people much brighter than me work on today. I have no idea what large impact these will have on the world a decade from now, even 5 or 10 decades from now. So, but I do think we should be thinking about it. And I think that I was heartened to, when I was reading and doing research for this, that some of these people were trying to project and think about what this could do in the future. Now, a lot of the times they were pretty far off. But I think that it doesn't hurt to start the conversation now and to work together to perhaps see what this might mean in 10, 50 years. And, for example, how we can protect against things that we're fearful of, and also support ideas that we think would be really great things that we can do with technology.
Thank you for an awesome keynote. I think, at least from my point of view, it's pretty obvious that automation of work is a trend that will continue, and that will probably worsen any social disparities that we have now. Do you have any ideas where to start a conversation about how technologists can help in this situation instead of worsen the state that we are already in?
Yeah, so I think that as I was thinking about this and when I found the computer professionals for social responsibility, now there are some groups that are working on these types of things. There's like Fairness, Accountability, and Transparency, a machine learning group and conference. There's some other ones that are trying to start these conversations about how we can be socially conscious actors when we do automation. I think that this would be a great thing to have a group around or a conference around or ideas around. I am no expert. I am just a person like you who is concerned. And I think that the more that we are able to share our ideas, I think that honestly, collectively, we are much more smart than any of us individually. And perhaps by having these types of debates openly, we can figure out maybe thoughtful ways that we can automate so that perhaps the impact is lessened. I also agree automation is definitely not going to go anywhere, and nobody's going to stop automating because of a keynote or because somebody has concerns. So I think that, yeah, having these conversations and collectively coming up with some good solutions or some good ideas is most likely the most powerful thing that we can do.
We have 3 more questions, and if you promise to keep them short, I'm going to take them. But I think probably, since it's such an interesting subject, would you be willing to do an open space for that?
Yeah, sure.
Sure. So basically, if you don't know open spaces yet, we have a large room there. You can just join there and make up your own EuroPython. So, and there's a, yeah, that's what it's for. So there's a whiteboard downstairs, you can use it. So we're going to put an open space for this on. I'm going to tweet also about it because I think many are interested, and there's like 3 more short questions. Yeah.
Yeah, cryptocurrencies have been just cited as one of the possible good signs of organization. I see them as the clearest example of what you said, when you have technological advance without social advance, because basically we have to burn oil because there was no other way than the proof of work to distribute bitcoins. Do you think this is related to some more intrinsic characteristic of computer scientists, that is this belief not just in current democratic institutions but in democratic processes in general, which makes it difficult maybe to have even just discussions, because if they are pointless, we will not have them?
Yeah, so you're asking like the anonymity that a computer allows me or that the internet allows me, does it break down these types of conversations?
Yeah, a more anarchic background compared to the idea that democracy can help us have social advances.
Yeah, I mean, this is a massive debate and something that I thought about including, but I just didn't have time to include. Like, for example, these people that believe that we should have parts of the internet where you have to be yourself, right? Allowing us to have, let's say, like, that use the internet as a system of political or social trust, right? And then you also then have governments using that to actively persecute activists and using the same, like, okay, I can publicly identify you, or I can easily de-anonymize you amongst big data, so I can actively persecute you. And this is this like thing, the more that we create systems that we can use for perhaps creating these types of like public conversations where I can represent myself and on a global stage and be an identifiable actor, is also a problem. And this is nothing new, right? This is something that since way before the internet, but it means that perhaps, yeah, in some cases, anonymization and these types of things are necessary to protect people. But I think it's a really interesting debate, and there was a few people that I wanted to include that are having this debate openly about e-democracy and so forth. And I think that it's fascinating, and it's something that yeah, hopefully we one day can trust, let's say, international institutions to help support people if they come forward publicly and they identify themselves and they speak of atrocities within their country or so forth, Snowden, that they perhaps then are supported globally and have protections globally. And I just don't know if we're there yet, unfortunately.
Okay, last question.
Okay, so my question was a bit based on what you said right now. How exactly do you come out after you find something that's just seriously unethical? Exactly like Snowden. He discovered that NSA was really not doing what it was supposed to do, and you got to a point where, hey, you're just getting everyone's data and you're doing something that's incredibly immoral. How exactly do you come out? I mean, you start to dispose information that's not really for the public, but if you keep on doing what you're doing, you're actually compromising more. It's a very moral shaky ground. What would be your recommendation or your view?
Yeah, so I think the protections for whistleblowers within computing, within internet, and these types of things, that we have to really evolve the conversation. That being a whistleblower for something like a massive multinational corporation or a massive multinational state intelligence agency, like these are things, where do you then go? Like who is supposed to protect you, right? And I think that this is particularly dangerous within our field. Like if I worked for a massive multinational corporation and I knew that we were doing something wrong, what am I supposed to do? If I come forward, I will most likely be fired. There will probably be a target of everything against my name, make me out to be an idiot, an unethical human, and so forth. And if we as a community have more of ways that we treat whistleblowers and more ways that we protect whistleblowers, maybe people would feel more comfortable, right? Because I also agree that what are you supposed to do? And in some of these stories, I'll be publishing a little bit more about this, and I'll be putting some stories on my blog of some of the folks and what they did. But for example, there is a man called David Parnas, and he was a computer scientist and worked in Canada for the US Department of Defense, along with a few other multinational defense agencies. And he wrote a big public resignation letter. And he sent it all around everywhere he could think of. This was the days of the mailing lists, not particularly public internet. And he publicly said, this is unethical. Everything that's happening within this organization is not something I believe in. I refuse to work here, and I don't know why my peers continue to do so. And I think that we can look at some of these references in history to perhaps think about how we can make some of the same statements, but that also we have to figure out how to protect one another when one another is willing to step forward and do that.
Okay, thanks for this, again, for this amazing keynote. So I'm sorry we took a little bit longer for Q&A, but I think there's no real time limit on ethics. And we're going to tweet and mailable, we're going to tweet and put it on the EuroPython pulse in the app for the open space. So if you want to attend, just watch out and enjoy your coffees. Oh, it was really awesome.
My pleasure to introduce Jean-Sébastien Beverlac, who's going to talk to us about CFFI.
Welcome, everybody. Difficult to pass after such a great keynote this morning, but my subject is not ethic, but technique. So if I give this talk today, it's because I truly believe in CFFI to improve maintainability and robustness of Python extension. I want to share with you my knowledge and my experience in order to convince you to give a try to a CFFI next time you need to write a Python extension. If you were at the Monday keynote, Armin Ronacher said that CFFI would allow Python to evolve one step further. I totally agree with him, and this talk will reinforce this vision. So, who am I? I'm Jean-Sébastien Bevilacqua. I write free software every day, and I'm a fan of open source, ecosystem, and philosophy. You can find a big part of my contribution on GitHub. Moreover, I work at Linegra. It's a French company that promotes free software, and it's this company which encouraged me to give this talk today. If you need support for free software, just contact us. We will be happy to help. So first, why do we need Python extension? I'm going to tell you my use case. So approximately 1 year ago, the new Vulkan API was released. Vulkan is a new graphic API that will replace OpenGL in the near future. So it's a low-level graphic API. You can create AAA games with it, and it's cross-compatible with Windows, Linux, and Android. Back at this time, I was enjoying OpenGL development, and with Vulkan, I saw an opportunity to improve my 3D knowledge and low-level knowledge. Welcome for the new. Hello. Sadly, with C language, you can have a system error like segmentation fault. And with Python, it can be very hard to track segmentation faults. Valgrind tool can help you, but it's still a difficult task that you won't enjoy, I can assure you. So, to write a Python extension in C, you have to make use of the CPython API. It allows you to create modules and add functions and classes in it. So after reading the very good CPython API, I start my C extension. It was clear and I felt such confidence, but it's still C. We have to fight against malloc, free, like usual, but because it's too easy, CPython API adds the reference counting and a cumbersome API. I almost give up several times due to the amount of work. So now we are going to see existing solution to resolve the complexity of C extension, but before that, let's see ABI and API mode. From now, I will often use the ABI and API words, so I need to explain clearly what I mean by these terms. API means Application Programming Interface, and ABI means Application Binary Interface. The API mode is what humans use. When you call a function, you need to know the name of the function and the argument to pass. So as a programming interface, it's all expressed in source code. The ABI is very similar. Think of it as a compiled version of the API. To be clear, when you write the program, you use the human API. Then, when your program is compiled, computer will access the ABI of the library. Maybe you wonder the goal of the ABI mode from a human point of view. We could just stick to the API mode. But accessing a library with ABI mode allows you to dynamically link at runtime, and tools can be used inside an interpreted language like Python, without compilation. Also, ABI mode can be interesting to use. You have to explicitly describe the binary interface, like you will see after. So let's see the existing solution to easily write a Python extension. Like I said just before, you can do it with the CPython C API, but it's a difficult task. The first one is Cython. Cython, like you may know, I think, you use an interesting approach. It can execute directly your Python code, and you can add new syntaxes elements by iteration. It's very good, but like you can see on the screen, when you start to add custom Cython syntax, your Python code is no more Python. And so you lose portability, and Cython becomes a required dependency. You should take that into account before using it. Such a high dependency can be dangerous. Moreover, the first goal of Cython is to improve performance of Python, not to wrap C library. Cython can be compiled and thus supports API and ABI mode. Another solution well known is C-types. C-types is a built-in. It's a very good point because you can be sure C-types is always available. With C-types, you don't need compilation. It works only on the ABI mode. You dynamically link to a library during runtime. But like you can see on screen, to C-type, you need to learn a new API. You have to translate your C header to the C-types API. In this example, I declare a point struct and get back the vector size function from my C library. Like you can see, it's error-prone and cumbersome. If you wrap a very big library, it will be painful, and it could lead you to segmentation faults because of mismatching ABI. Another good part. 7 years ago, two very, very smart people, Armin Rigaud and Maciej Fitzgeralski, created CFFI. You may know these names since they authored PyPy2. That's not a piece of cake. For information, PyPy is an alternative Python interpreter with a JIT. So at first, CFFI was an alternative to C-types. It was working only on the ABI mode. Later, the API mode was added and revolutionized Python extension ecosystem. Before CFFI, to create an API mode extension for Python, you had to use the CPython C API or Cython, which at that time was working only with CPython. With CFFI, extensions are working with CPython 2, 3, and PyPy without changing one line of your code. That's good. Now you understand ABI and API mode, I can show you how it works with CFFI. But just before that, let's introduce another concept of CFFI. This one is a lot simpler than ABI and API mode. In the inline mode, everything is set up every time you import your Python code. Yes. In the out-of-line mode now, you have a separate step of preparation and possibly compilation that produces a module which your main program can then import. Of course, inline mode is available only for ABI, since API mode requires compilation. So let's see some examples. These first examples show how to work with ABI and inline mode. This is the first feature supported by CFFI, and it's exactly what C-type is done for. So we can compare it to C-types. Like you can see, with CFFI, you just pass the C header to CDEF and open your library, that's all. No API to learn. It's just magic. CFFI syntax is clean and intuitive. Like I said, with C-types, you declare manually the library structure. Thanks, but no thanks, C-types. So I will just show you a small demo of the ABI mode. Okay. On this example, with DL open none, I load the entire C namespace, which contains printf function, the C printf functions, like that. So to let CFFI know this function, I had to give it with cdef. Then I create a char argument and I can pass it to the printf function. Then I print a string with our char argument. Let's try. It works, okay. So I print with the C printf function, not with the Python printf function. That makes a big difference. So like you can see, it's very simple to use. Okay. So CFFE goes one step further with its API mode now. Syntax still similar, but you can notice a difference. We pass C code to CFFI with the setSource function. Then you just ask CFFI to compile your module. Your Python extension is robust, fast, and easy to maintain. With this API mode, you can't have segmentation fault due to a mismatching API. You can if your code is not well written. Moreover, it adds the convenient features, like you can see. You can replace useless value by 3 dots, but I will not go into detail on this feature. So just a simple demo with the API mode. I think I have a small problem with my terminal. Okay. Let's continue. So now the very interesting part. I'm currently building a 3D engine with Python and the new Vulkan graphic API. Like I said to you, I created a Vulkan wrapper directly in C with the CPython C API. But if I'm here today, it's thanks to Armin Rigaud, because when I show him my Vulkan wrapper on IRC, he tells me you could have used CFFI. And then he explained me advantages of CFFI. It took no more to meet a new challenge, write a Vulkan wrapper directly with CFFI. Was I ready to lose months of work? Yes, it's a hard decision because I spent a lot of time of my wrapper in C, but I definitely made the right choice. I'm going to show you why. So, like all engineers, we love statistics. The Vulkan API is huge. 100 of functions, 100 of structs, 100 of constants. More than 5,000 lines of code just for the C header. And there is an XML descriptor. So wrapping all this API in plain C is just madness, as you can see with these numbers. More than 62,000 lines for the generated C file. But I'm crazy enough to have done it. Whereas with CFFI, it's only simple and clean Python code. To give you an idea about time, it took me 1.5 months for the C version and only 2 weeks with CFFI. This time is only on my spare time, so I think it would have taken only 1 week at full time with CFFI. And moreover, when I got an open issue on GitHub, I can fix it in 1 hour maximum because it's just Python, clean and simple. The C version was too difficult to maintain. So, how it works? In both cases, I use a generator because the wrapper, like you saw, is very big. So Kronos Group, the group behind Vulkan, did a very great job with great work with Vulkan. All is open source, and you can contribute easily to GitHub to the spec too, the spec. It provides an XML file that describes the API. So my generator takes this XML file as input and generates the Vulkan wrapper as output. By doing a generator, I can update the wrapper in 2 minutes when a new version of the API is released. So basically, here's the steps. First, I load and parse XML definition. Then I generate the data model. Then I generate the Python module with Jinja2. Jinja2 is a template engine. I think you know it. It's very famous in the Python community. So parsing is done with XML2dict package. XML2dict is a Python module very good to parse an XML file without edge. So it transforms your XML-dict into a hierarchical Python dictionary. So the first step is done. We have a good data model, easy to parse. So we can pass it to the Jinja2 template. I focus only on this part because that's where the two modules differs. What you see here is the folder structure of the C extension. So we compare the Python C extension with the CFFI extension for the same wrapper Vulkan API. So here, what you see is the folder structure of the C extension. Like you can see, there are too much things involved. So to keep code maintainable, I had to split it up. Line of code is a good indicator because you can see it's very huge, but what is more important is the complexity of the code. Like you can see, it's huge. Moreover, with C code, you have to manage memory yourself, and this is very, very error-prone. Now, the same thing with CFFI. It's very different. Despite of its looks, what you see on screen means a lot. With CFFIs, I did not need to think about architecture. It was very obvious, all in one file. One more point for CFFI. But you don't have to trust my words when I say CFFI is better. Let's see it in action and you will understand. Constant is the easier part and both cases are simple. In C, we just use the CPython C API to add constant to our module, but there is a difference. We have to take care about the variable type. With CFFI, it's just Python and it's dynamically typed variable. But only with constant, you don't go far away. Next step is to create binding for strict. Here's the difficulty. But in Python, there is no strict concept. So there are classes which is similar. With CPython, you have to handle the del init get for each member. And I don't handle the set. So you can't, with my C wrapper, you can't update an object after it is initialized. You have to use malloc to allocate memory for your object in the new. In del, you must free your object. In init, you have to parse each parameter with CPython utils function, which can be tricky. And in get, you have to convert your C strict to Python object. I can assure you, it takes me a lot of time to figure out how to properly do it. Code is so long that I can't show you an example on screen. With CFFI now, it's 40 lines. CFFI handles for us object allocation and deletion. I just use plain Python to handle all strict initialization in a generic way. I repeat to be sure that you understand, this generic new function works for all my stricts. With CPython API, the step I showed you must be done for each strict, and there are hundreds of stricts in the Vulkan API. When you really realize these benefits, you just fall in love with CFFI. So what I showed you until here is the ABI mode. Let's try the fast and robust API mode now. We are going to wrap a C library with the API out-of-line mode. This mode is robust and fast, but you need compilation. I don't know if you know ShadRC. It's a library we are going to wrap. So ShadRC is a free software done by Google and gives you the ability to compile GLSL language to SPIR-V binary. GLSL and SPIR-V formats are used to create programs for your graphic card. If you just do some 3D development, you may know this language. So to create an extension with the API mode, I usually create a folder dedicated to CFFI that I name CFFI build, and I recommend you to do so to keep a clean separation of concerns. So on the screen, shaderc.h contains shaderc function signatures and struct. We just copy-paste the header provided by Google, and CFFI handles it. I don't need to modify it in this case. PyShaderC build folder is used to generate the Python extension. So next we have the PyShaderC folder containing our wrapper. And finally, we'll take a look at the setup with a special feature of CFFI. So the definition first. Like you see, we first read content of the shaderc header and pass it to the cdef function. That's all for the definition. Sometimes you need to rewrite your header, but in that case, the header is so clean that I can give it like that to CFFI. So 3 lines, and CFFI knows how to handle this library. It's very beautiful. So now the building part. With these few lines, we tell CFFI to compile the cells with statically linked library shaderc combined, and to name the extension PyShaderc. Shaderc combined is a static library that we have to compile before running this CFFI part. I don't show you how, because it's not directly linked and related to CFFI. You can look on GitHub if you are interested in. Like you can see, there is no C code involved. We just tell CFFI to open a Python portal to the shaderc library. Here again, it looks like magic. So now we have to use it. Currently, our extension is ready, but we remain dependent of CFFI. It means that, for example, if you want to pass a pointer to a function, you have to use the CFFI utils function. But when using your wrapper, your users shouldn't need to know CFFI. It's just a dependency. So we are going to write a small Python code, especially for that. This code is located in PyShaderc init and is loaded automatically when you import your module. So this is the init file. So first we load our extension PyShaderc, which contain ifify and lib modules. So the lib modules contains all functions and struct related to our library. And ifify is used to interface with our library. Let's examine the compile into SPIR-V function. Remember, the shaderc library allows you to compile GLSL to SPIR-V. So this is this function. All functions defined in our extension can be accessed through lib, the lib object. If you take a look at the compile line, here, the third line, we can pass pure Python types like int or string, and CFFI converts it for us. It's clean and intuitive. A small note, with Python 3, string must be bytes. Next, shaderc returns a pointer to us. We have to tell CFFI to convert it to a byte Python object. Like that, I can use it in my program with NumPy or something else. So we first get back the pointer and the length, but we can't directly copy the data to a byte in Python because byte type is immutable. So we have to copy data into a byte array, a temporary byte array, and pass it in our bytes object. If you take a look at the FFI1memmove function, it's very similar to the memcopy C function, but directly in Python. So here, I'm doing memory manipulation directly in Python. Good, that's good, CFFI. So in bonus, CFFI provides a setup tools extension. You just add the entry CFFI modules, and your extension will be built by setup tools. It's a good way to package your module. So let's see the example. Okay, so we can enjoy the result. Let's play a simple game, very simple, just for the demo. So, like you will see, I'm using the new shiny Vulkan API with the Vulkan wrapper and the PyShaderC wrapper to convert GLSL code and put it inside the graphic card. So this simple game is written fully with Python and make use of the new shiny Vulkan API. Yeah, so very, very simple game. Not impressive, but we can do impressive things now. Before finishing this talk, I have to thank two very special persons. Without them, this talk would not exist. So please welcome the creators of CFFI, Armel Ringo and Maciej Fidzialski. I think they did a lot for our Python community, and they are very valuable person because I talked with them yesterday. Very nice. And thank you so much for your incredible work. You make the greatness of Python, and you deserve our respect. Thank you again. So I hope that, like me, you enjoyed this talk. If one day you need to use a C library or you need to improve performance of your code, please think about CFFI. And thank you for your attention and have a nice day. If you have questions, yes.
All right, do we have any questions?
Thank you for the talk. Just a quick one. So the demo was Python 2, right? Not 3, because 3 takes bytes, not strings.
Can you repeat, please? Because with the echo, I don't...
The demo was using Python 2, is that correct?
With Python 3. 3.6.
Because strings are passed as bytes. No.
Yes.
Thank you.
Yeah.
Thank you for the talk. Is this only interfacing to C, or can you interface to C++ as well?
So currently, I think it's only C, but you can, when you have a C++ library, because PyShaderC is a C++ library, you can do a C header for your C++ library, and then you use it with CFFI.
Thank you.
Hi, how about interfacing an existing library that does its own garbage collection?
Can I will come because I don't understand from it. Good question. Maybe Armin can help us because it's very specific.
So garbage collection, well, you need to do it completely manually. It's a story. Like, however garbage, whatever garbage collection is needed by your C library, you need to do it manually. So there is no automatic garbage collection at the level of CFFI, simply.
Hi, is there any specific pain with handling callbacks, functions, stuff like that?
With the recent version of CFFI, there is a very good feature about callbacks, so you can, I handle them. With the Vulkan wrapper, there is a lot of callback. If you know Vulkan API, I don't know. And I handle them, I can generate them automatically. So you can take a look on my GitHub. If you need callback with the FFI, it's a good example.
All right. Well, if there are no more questions, I can't see any last minute things. All right. Thank you very much for your talk. Let's give a hand to John Sebastian.
Thank you.
about coding competitions using CPython and PyPy.
Hi there. Thank you for joining. So, my name is Alessandro Amici. I work for BeOpen, a software company in Rome. We use mostly Python, and since I do my hobby most of the time involve programming and coding, I often happen to do coding competitions. It's a very fun sport. I'm just an amateur. I'm not very high in the rankings. I do it as a weekend hobby. But I think I learned quite a lot about how the general theory of coding competitions, and I found it was fun, but it also helped me being a better programmer overall, even if it's not what you would expect. It's not that you know so many new tricks that you use. It's really a more general attitude toward programming, and this is what I want to talk in this talk. The first point is, why would you do coding competitions with Python? Usually you would say that if you want to compete with others, you need to have a language that is as fast as possible, which is true. And in fact, most of the competitors use one of those three languages, which is C++. For typical coding competitions, this is the Google Code Jam. It's the largest single coding competition that is online. And it's the main topic. It's the example that we use throughout the talk because it's the cleaner and easier to track. The three most used programming languages are C++, Python, and Java, especially in the beginning, in the initial rounds. Verification rounds, it's open to everybody, then you need to qualify to further rounds, and then the audience becomes smaller and smaller until in the final round, only a handful of people, actually 25 or 26 of the very best competitors end up. And you see even if half of the people, compared to the C++ crowd, the Python crowd, it's more or less half at the very beginning. It becomes 1/10 at the end. But still, there are people who do use Python in the finals. And the reason is that there have been cases where the only solution that could be submitted to one of the problems was a Python. In 2011, round 3, it's one of the final round, only the top 25 competitors qualify, and user Linguo, who is a proficient Python programmer, he codes in 9 or 10 languages in the competitions for fun, but then when things get tough, he uses Python, and he was the only one. He was ranked first because he solved the large input datasets of problem D with Python. No one else managed to do it, not even the very best C++ programmers. In 2013, round 2, something, if you want, even more interesting happened because B-Merit's one of the guy who can win the competitions, and he is a C++ guy. He uses C++ almost for everything. But the last problem of the round 2, he managed to solve. He was the only one who solved it, and he solved it in Python. So he switched in just half the time, or even less than half the time that the other C++ competitor had. He managed to implement the Python version and to get it. Now, notice that he finished at 2 minutes, 29 and 54 seconds. It's 2 hours and a half is the full competition, and he squeezed the last winning submission just 6 seconds before the end. This is also one of the things that you learn, never give up. Finally, in the 2017, this happened last month, user Kevin Sogo, who is one of the very, very younger and very best in the scene. He is a Python guy. He uses mostly Python except C++ when he thinks that he really needs the speed boost. And he managed to finish it's one of the only 4 people who submitted a correct solution for the final problem, and 3 of them used Python, including Kevin Sogo. So the point is, it might be, in certain cases, a good idea to use Python. Let's try to understand why. Also, during the time, more and more people are using Python, both in the initial rounds where, there are a lot of people who are not as good as in the final rounds, but also in the final rounds. It's actually, in the past 2 years, Python actually overcame Java as a language in the very final round. So the plan for the talk is to give an intro to what is exactly to compete, for example, for the Google Code Jam. Then we will try to solve the problem live. They say never do live coding. Let's see. And then we try to understand from the theoretical point of view what is that really matters in a coding competition. Then once we have this, we can try to do a programming language comparison to understand what are the advantages and the weaknesses of every language. And then we see what we can do, what we have learned, that is, what if I want to do this competition for fun, and can I actually get something for my day-to-day coding, or even for life. So, Google Code Jam. That's the main entry point. It's a competition. It's run once per year. It has several online rounds and just one on-site round on a Google location. It has quite sizable price, a total of $20K of dollars. And then usually you need to solve, depending on the round, from 3 to 5 problems. There are problems with a non-correct solution. So there are other kinds of competitions where the complete solution or complete optimal solution is not known, but you can judge a solution if it's better than another. Here, it's an on-off. Either it's correct or it's incorrect. You can program in any programming languages because you do it on your computer. You download sample input, you run code on your computer, and you upload the output. If the output is correct, an online judge will decide if the output is correct. The competition is time-boxed in a few hours. 2.5 hours is the typical length, but some are longer, some rounds are longer, some rounds are shorter. The runtime of your code, it's a few minutes. 4 minutes for the small input, for a small data set, and 8 minutes for the long data set. So every problem usually has a simpler data set, and then a more complex, more broad, large data set, and you get independent scores if you get the first or the first and the second. Finally, you get ranking based on the problem score, that is how many problems you solved and how difficult they were, that you have given the score in advance, and your submission time. So you need to be fast in submitting the solution. So you get points if you are correct, and you get an advantage if you do it fast. So usually a problem is done like this. You have a problem statement that describes the universe actors, rules, parametric rules usually, and a question. What you want, what is your task? Then you have limits. This is very important. The parameter and the initial condition of your universe are described as we will not give you more than n actors or so on, 10,000 or 10 or something. And there are different limits, usually for small and large inputs. This is the main difference. So typically, the problem is simpler to solve. You need less insight to solve the small input and more more steps, more insight to solve the large input. Then you have sample test cases with the solutions, so you can check if the solution you've developed is actually working on a sample data set. And then you have the real test cases, the one that you download, and if you solve them, you get points. So typically, the problem solving is, you have two things to keep in mind. First, you have constraints. You have your CPU, RAM, storage. This is what you usually think as important thing in solving a problem with a computer. And then you have the code running time. Your code cannot run more than 4 minutes or 8 minutes, depending on the input. But then you have wall clock time. That is really the big part, because you need to solve as many problems as possible in the 2.5 hours that they gave you. And if you solve it faster, then you are higher in the ranking. Coding phases, we will talk quite a bit about those. Usually, the steps are this. You read the problem, you try to understand how to map the universe in some algorithm and that solve the question that you are given. Then you need to implement the algorithm, actually typing it in. And then, depending on the problem, you may need performance tuning or debugging. Debugging is anything that you do after you are pretty sure you coded it well and it doesn't work. And performance tuning instead is when you realize that the solution, that the model that you have, is too slow. And then you have runtime. Runtime, it's how much time you need to download the stuff, run, and upload it again. Now, to give you an idea of how this looks like, we will try to do a live training session. That is, we read a problem, and we try to code it, download it, run, upload, and see if it works. Hopefully, we will do it in time. Now, the reason that the problem that I'm proposing, I actually did live in one of this year rounds, and I made it in 7 minutes and 11 seconds. First time that I saw it. Now I saw it already, so hopefully it will not be long, and still was not enough to qualify. So the first 1,000 competitors qualified, and I was 1,146, so tough luck. So now, the hard part that is switching this and going here. Okay. So can you read the statement? So usually the problem statements are, the universe is described in some kind of funny or interesting way, so you don't lose the fun of it. So it's about Annie is a bus driver with high-stress jobs. He tried to do something, and in the end, he wants to do some horseback riding for fun. So today, Annie, now it's describing our universe. We need to capture how to make this into a code. Annie is riding her horse to the east along a narrow one-way road and runs west to east. She's currently at kilometer 0 of the road, and the destination is at kilometer D. Kilometers along the road are numbered from west to east. There are n other horses traveling east to the same road. All of them go traveling forever, and all of them are currently between Annie, horse, and her destination, and the I horse has initial kilometer Ki, and traveling at the maximum speed Si. Then he says that horses cannot overcome each other, and the question is, you can go at it doesn't have any maximum speed, you can go at whatever speed you want, but as long as it doesn't pass any other horse. So the problem is that we have horses running on a segment of a line, and we cannot pass them, and we want to choose to ensure smooth riding for her and the horse. Annie wants to choose a single constant cruise control speed of her horse for the entire trip, from the current position to the destination, such that her horse will not pass any other horses. What is the maximum such speed that he can choose? This is very typical. This is very simple universe. Then you have description of the input. This is typical input. You have number of test cases, then a line with D and N, how many other horses, how long you need to go, and then N lines with where every horse started and what is his speed. Output needs to be a string where we say what is the cruise speed velocity. Limits. For the small data set, the interesting part is that we have only one or two other horses. In the case of the large data set, we have up to 1,000 horses. Now, you have an input, and for this input, you know what is the output. Typically, some of those, the problems are quite standard in a way that they give you this is my solution, my scaffold solution. I read the number of test cases, then I range on test cases, I build some kind of result, and I print the result. If I do run this right now, I just get 0 because I don't do any computing. Now, this is quite simple, or at least quite simple for me. I know that since horses cannot overcome what every horse has a maximum time when he reaches the final destination, and somehow I want to look just for the slowest horse, that is the horse that will reach the destination in the maximum time, and then I want to go there at the same time as him. That's easy. I mean, even if you do not practice coding competition, you can get it done in slightly longer than 7 minutes, but it's very fast to do it once you have the hang on it. So basically, what I'm saying is that first I need to read all my D and N. So I get, for every test case, I get an input. I split it in D and N, which is the order in which the first line is given. Then I have a number of horses. So I do a for range N. I need to read N more lines, so I go input. Again, these are two numbers, so I split it and I map it with int. Everything is an int. And then I need to do a list here, because map returns a generator. Here I don't need it, but here I do. Let's see if this works. Usually you do something very rough. I want just to see, okay, I can read it more or less. So now I have the result. Now for every horse, I know I can't tell at what time the horse will be in the at D, at the end of at my destination. So I have K and S in I, and my result is the maximum of result itself, D minus K. So this is the distance that that is remaining for the horse, divided its speed. Now Python treats very nice, so this is already float and everything. Let's see if this works. And this says that this is the time it takes, since I really don't want to have the time, but I need to give the speed. I think I need to divide this by, to do the divided rest. Let's see if it works. And yes, so this was fast. Now, how do I know if this is correct? I need to download a practice solution. I already am in the correct thing, so I replace it. Now this is I'm really testing if it's not on the sample test case, but on the real stuff. During the completion, this is how I get the score. I need to get the small input. Yes, very fast, so I save it to the small out, and now I can submit my solution, which is small out, and see it's case 1, case 0. Okay, this is a very typical mistake. Okay, now this is debugging. Sometimes you have a problem and you need to understand what is the problem and solve it. Let's see if this was the real problem. Submit. Correct. Great. Now, in this case, I already know that I can handle 1,000 horses as well as few, so I just go and download the large case. The large problem, I save it to large in, replace, then I do the same with large in, and I save the output in a large out, and I need to select it. Submit. Correct. Great. So, this is how typically things works for very simple problem. What is interesting is that first, there was no need to yes. Thank you. First, I didn't hit any of the constraints. The problem was so simple that really CPU, RAM, storage, running time was not a problem. For the large data sets, it was a couple of seconds. So the only thing that really counts in this case was wall clock time, because you get, it's not a score, it's not part of the score, but it is something that makes you higher in the ranking. So if you look at more or less the various coding phases went, modeling was just slower now because I need to read the statement aloud, but usually it's fast. And then coding, it's usually fast. If you don't have any hit, performance tuning, it's not needed. In this case, was not needed. And debugging was just tried. I mean, just test the thing work. You have a small problem, but you fix it immediately. And then runtime was 0 as well. So the 7 minutes, you can't submit a problem in 5 minutes. This is what the really good people do usually for at least 1 or 2 of the problems. And everybody has a threshold where the problem is easy enough that this is your target time if you want to compete. Then there are generalized solvable problems. There is something that you are able to solve. It's not easy, straightforward as this one, but it's something that you're able to solve. How do you recognize these kind of problems? Usually, most of the time, especially when you begin, there's still no real need to keep the constraint, because usually the main problem is to do the modeling. You can take from 2 minutes to 20 minutes to do the modeling that is going from the text to an actual algorithm to data structure, etc. And then coding is usually, again, not the real problem. It's usually performance tuning you don't need. It's very, very rare, only if you do some mistake at the beginning. And this is the real place where PyPy beats CPython, because it needs even less performance tuning. The problem is debugging. The real key and the real reason Python has an advantage is that if something goes wrong, if you did a mistake in implementation or even a mistake in the modeling, if things don't work, you need to understand where, how, and when. And this is the debugging part is where Python has a huge advantage. Oh, first, the language that you know the most is the one that has the advantage, but Python, if you know more than one language very well, Python has the advantage to have stack traces, very powerful print statement. So debugging is where Python shines, really. And it's the largest and more risky of the coding phases, because maybe you don't need any debugging at all, even in C++, but if you do, it might grow. It's easy to get 1 hour stuck on a problem that you know you can solve, but just you made the silly mistakes somewhere. So how do you recognize a simple, unsolvable problem? This depends on you, really, because there are usually, if you keep an eye on the scoreboard, you see that the pros can submit correct solution to a problem very fast, or I mean, that it doesn't take long. So you know that this is a simple problem in the general way, but it's not solvable for you if you don't know how to do the modeling. This is where there is really the big stuff, the big difference between experienced programmer or experienced competitor and new people. The other part is debugging, because if you have you might have a model that you, at the end, you find what is the algorithm, data structure, data scribe, but if the things are at the limit of your capacity, the time, most of the time, will be spent in debugging again. So these are the real 2 key assets. So the key assets is your time, and the 2 big, and the way you spend your time is mostly modeling and debugging. The rest is usually a fraction, or in the typical case is a fraction. Then you have generalized unsolvable problems, which is something that is completely out of scope for you, and you can easily recognize because the pros are having hard time to solve it. So this doesn't care. you may not care. Language comparison. So why people still use C++, but a lot of people are using Python. CPython and Python, they're slightly different. Since we are interested in Python, I have them separated. Now, the point is, in the modeling part, both Python and, CPython is the best because you have access to a huge number of libraries. Sometimes the solution is just to know, you already know a library, and you just need to code how to describe the problem to a library, and the library solves it. With PyPy, you have slightly less an advantage because some of the libraries are not working, and with C++ and Java, usually it's harder to install stuff, so unless you have a perfect setup, you may not, and also interfacing with libraries is harder, so there are many more competitors just go with a straight typed solution, not going for a library. Coding. The coding time in Python is excellent because it's very terse, you can be very clean, and the same, it's C++, Java, it's a little bit longer, but coding, it's not really that important. I mean, unless there are thousands of if, because you have a very strange problem, the coding, it's not what make a difference. Performance tuning can, in some cases, be important, and this is the reason why the pros use C++. Performance tuning in C++ usually you don't need to do, because the C++ is fast, and it's the compiler that does most of the optimizations. Java and PyPy have a JIT, a just-in-time compiler, so it's fine to use them. CPython sometimes are very stupid optimization that you need to track, and if you don't, it can be very slow. Usually they are very ingrained in our brains, so it's very easy to do performance optimization, like not repeating a len or a function call inside the loop, but still you need to keep them in mind. So it's not so good. The point is that with debugging, CPython and Python is where, and PyBytes where they have the big advantage. And as we saw, that is the big, big risk. So now we move in the what we learn about in coding competition. The first point is that strategic thinking. The wall clock time is the paramount asset. This is something that it was not clear to me at the beginning, and then you need to optimize that, manage your time, and be sure to know in which phase you are and if you are doing the right thing at the right phase. At a higher level of strategy, you have problem selection. Usually, you should go for the simpler problem first. This means that you go and crack and put you put aside the points that you have, that you can, the lower hanging fruits. And then also, among the simple problem, usually you should consider the simple solution to the simple problem. Brute force works in a lot of cases in the first rounds of the code jam, and once you did the brute force solution, you have a working solution. Then probably to do the large, that would be not enough, but at least you can test if your fancier solution gives the same results as the brute force. Then you always need to keep focused and keep an eye on the scoreboard. That is, first, you need to check what other competitors are doing, especially the pros, so that you know if something is actually solvable or not, so you don't lose time in something that is too much out of scope for you. And then you really need to try work on problems that can make a difference for you. In one instance, I had problem doing a simpler problem, so I set it aside and tried to do a more complex problem. When I solved the small for the harder problem, I saw that I didn't have a chance. If I went back to the simpler problem and solve it, that would not have been enough to qualify. So I tried to see. I gave myself 20 minutes to think of how to solve the hard problem that no one was doing. So it was really an hazard, but there was no way to win otherwise. And after a while, I noticed that the problem was really mostly a trick, that the same solution of the small problem would have worked for the large, even if it didn't look like. So at the very last, I just tried. I was not losing anything because I would have not qualified anyway, and it worked. So just trying, I mean, I had an insight, but it was really, this is the only thing that I can do right now to have a chance at winning. So strategy, it's a big player in this, in competitions. The other things that you learn is to focus and stress management. At every time, you need to have both the round strategy and the problem strategy. That is, you are doing the single problem, but you need to qualify for the whole round, and this is something you need to go up and down in the strategy level to be sure that you are employing your time as wisely as possible. Then something that is very important is keeping focus in a way so that you don't make mistakes while coding. Every mistake may cost you debugging time. That is, the worst that you can do is to do a mistake both at modeling and at coding. Usually coding mistakes are easier to track. If you do a mistake at modeling, then it's much harder to go back. But one of the points is everything in modeling your problem and coding should be kept as simple as possible. This is quite strange. You think that you may do fancy stuff, but no, most of the time doing the most plain solution is the more easily debuggable, and so it's the one that wins you, that qualifies you. Then one thing that, this is a mistake that I do very often, you need to be ready to question all your assumptions. Sometimes you decide that the solution to a certain problem has a greedy solution, so you go with that, and you never question that assumption, which was just an assumption, and that is something that you need to learn somehow again and again. Always go back and be sure that what you are doing is you didn't leave anything back. Then there is stress management. This part, somehow, I didn't think was so important. Instead, the fact that, I mean, you need to keep calm in the face of a ticking wall clock. And this is not easy. I'm competing since 5 years, and still when the competition starts, I can feel my heart rate going up and feeling sweaty. And so keeping this in control, keeping control over this, it's really one of the things that you learn if you want during this hobby. And it's something that is very useful in all kinds of situations. Again, there is the fact that you also need to keep calm in the face of the risk of public shaming, or I mean public humiliation, because what you submit, then it will be made public. The solutions in the Google Code Gem are public. So sometimes you know you're doing something really horrible, it should be optimized, but time is what counts. And in the end, this is what counts for you. And if then other people try to learn and download your code and see your code and say that, oh God, this is really horrible, it's fine. Still, you need to keep calm in face of this. Then there is something quite amazing, that is the never give up. This happens with all the sports. But with coding competitions, the fact that this stuff is get very much closer to the way we program, and sometimes if you, like in the case that I have, if you have just one way to get out of a situation, you may try it, may not work, but you know that you did the best, and if it works, you actually get out of, I mean, in my case, I qualified, and you can get out of your problem. Also, you can imagine Be Merry coding like crazy. I mean, the final code that he submitted 6 seconds before the end was something like 3 pages full of if and everything, and you need to say, okay, I go on doing this, even if I'm very, very tight in time. I'm almost certainly I will not have time to run it and submit it, but if you do it 6 seconds before the gong, it means that you really believe that. So how do I start, or how do I get better at competition? You get this advice online. The most important thing is practice. The second most important thing is practice again, and so is the third. There's nothing like that is more important than practice. But now, for real, so something useful. First, practice. You need to practice real-world competition from start to end with a timer. The wall clock, the fact that you feel pressure and keep the stress and focus needs to be real even in competition. Then you need to go for volume first. Do a lot of simple problems. Even if they are obviously simple, you need to get your muscles, coding muscles going. Then you go to problems that are more to your limits. You need to understand and try to figure out what are the problems that are your limit and try to go for that. Then learn from code of other competitors, and then learn libraries. There are a lot of libraries. These are the ones that I find most amazing in coding competitions, but a lot of libraries just make a lot of things much simpler. Then you need to learn data structure and algorithms. This is the course that I followed, which is amazing, and I invite everybody to use it. So what do I learn from everyday programming? Basically, the point is modeling, coding, performance tuning, and debugging is the same. And the point is that performance tuning and debugging have a much lower time scale. So this is where you need to optimize your wall clock management time. Also, strategic thinking. Always try to get to the low-hanging fruits before doing the big architecture, and always keep an eye on the scoreboard. That is, what is exactly that is useful now, and what is the most useful thing that I can do now. Finally, focus and stress management is the thing that I really like the most. That is, if you have a bug in production, or you're doing a hackathon, you have time-boxed, you want to solve something as soon as possible, and all the keep calm in the face of the clock and keep calm in the face of people looking at you, like in client-facing problem-solving situations. This is something that once you do coding competitions, looks much simpler to do. Job interviews as well. I mean, you have someone looking and watching every keystroke. Or if you're trapped in a fire, you need to say, okay, keep calm, I need to solve the problem, not to panic. Then again, strategic thinking it works exactly the same also in your life, and keep an eye on the scoreboard. It's as well one of the most important things. So I thank you for your attention, and I'm ready to get questions if you want. Thank you.
Thank you for the talk. I have a very quick question. It could be a bit specific. Can you hear me good?
I hear very badly. Can you speak
closer
to the microphone?
Is it better?
Yeah, better.
Okay. So this could be a bit specific. I am like the Python newbie. I mostly use like the C, C++. I was curious why Python is better for debugging. Like what are the advantages over the
okay.
C++?
The first and most important point is stack traces. This is where Python shines. Stack traces are usually very, very useful, and you get them for free immediately. The other point is that the print statement, which is really the only debugging tool that you use in coding competition, it's much, much powerful. So you get a very nice representation of a lot of data types, especially if you use standard data types, which is what you do most of the time. And in case you are forced to go into the debugger, which you really want to avoid, you just do import IPDB set trace, and the introspection of Python helps you really a lot. I did not much C++ in my life, so I'm probably not an expert in debugging, but when I needed to port my Python libraries to C++ for performance reasons, even if I already knew what I wanted to do, it was a pain that every small details needed much more time to be debugged.
Okay, thank you for your talk. And I wanted to ask, because you said that we have the time limit for execution also. It was like 4 minutes for the small data set. And how is this measured? Because you are downloading the input and uploading the output. So how to do it?
You have a timer. When you download the data set, you have a timer, and you can only upload the result within 4 minutes. If you go out of after, you're not able to upload the data, the solution.
Okay, so basically, if you have more powerful computer, then you have kind of a lot of advantage.
Yes, and quite surprisingly, this doesn't count most of the time. In my whole career, I mean, I did a lot of practice and a few code jams, 5 probably, and I think only once I really had something like a solution that ran in 5 minutes instead of 4. And it was something like a trivial mistake that I made. So yes, it may happen. that a faster computer or a faster language is different, but it's quite rare.
All right, I think we've probably got time for one more question, if anybody... No? All right. Okay, please join me in giving Alessandro a hand.
Thank you very much.
And please remember, you can rate all the talks on the EuroPython app and leave constructive comments. Thank you. just wait for the last few stragglers to get through the door. Please join me in welcoming Emma Gordon, who's going to talk to us about how we should evolve code instead of writing it.
Hi, thanks for coming to talk. First of all, can everyone hear me okay? It's like wave at the back, you know. Cool. Okay, so I'm Emma. I am the lead Python developer at Cambridge Medical Robotics. We're a startup working on developing the next generation in robotics for keyhole surgery. That is pretty much as cool as it sounds, to be honest. That is pretty much as cool a job as it sounds, to be honest. So if you are interested, we are hiring. I'll put a link up at the end. So how do we get from that to the topic of this talk? Well, I'm also on the organisers of the Cambridge Programme Study Group. We meet up about once a week to study topics in computer science. And about a year and a half ago, we were looking at machine learning, and in particular, genetic algorithms, and how we could use those to evolve some code. So having managed to get that to work, I pretty much instantly became fairly concerned about my job security. So if we think about it over the course of history, the kind of way we've lived our lives and the kind of work we've done has massively changed as a result of technology. So for instance, in agriculture, we used to have a large majority of the population working in the field, sowing seeds, harvesting crops. We developed things like this, and now we've kind of freed up most of us to work on other things. A more recent example, you walk into a supermarket, I'm sure you've all seen rows of these self-checkouts where you might have had lots of people working at tills. Now you can just have a single person staffing these. You might think, okay, well that's quite repetitive work, things that are easy to automate, but increasingly with artificial intelligence we're seeing even higher skilled work coming to the firing line. So this is IBM's Watson machine. If you've not heard of this before, it was developed a few years ago as a supercomputer to compete at the US quiz show Jeopardy! This is a contest in which the contestants are given the answers and they have to respond with what the question was. So figuring this out involves kind of a mixture of natural language processing, having a big store of information of general knowledge that you kind of retrieve data from, and also kind of applying some machine learning techniques to figure out kind of connecting all this together. So this definitely won at Jeopardy! It's defeating the champions, human champions at that. And it's now been applied to some other areas as well. So we have things like medical diagnostics, where there's a huge volume of information, so new clinical studies being published all the time, journal entries, the patient's own medical history. This is a lot of data for a doctor to deal with when diagnosing a patient. This machine can instantly have all the latest journal articles. It can read them all in a time that a doctor simply wouldn't have, and have all that information available to it. So it's potentially able to make more accurate diagnoses, particularly for uncommon conditions that a doctor may not have come across before in their working lives. You can also apply it to things like legal work, so preparing a case for a trial. You have lots of prior judgments to trawl through, lots of legal studies, that kind of thing. It can also be used as a teaching assistant in the classroom, so because of its natural language processing abilities, it can understand questions that students are asking and come back to them with their answers. So now we have people like doctors, lawyers, teachers, also having their jobs coming into the firing line from this rising technology. So what about our software developers then? So you might think, okay, hopefully we're okay, hopefully we're needed to write the code that makes this work. But as I said, it's looking at ways that you could generate that code rather than write it yourself. So how might you go about that? So one approach you could take is something called a genetic algorithm. So this is a type of guided random search algorithm. So as opposed to a systematic search, where you've got your kind of data structure and you're going to look for it, this starting one end and going through until you find what you're looking for, or a random search where you might say, okay, I'm going to look over there, now over here, maybe over there again, have I found it yet? Nope. A guided random search is where you look in a few places, and then based on what you find there, you make a decision as to where you should look next. So this makes some assumptions about the data being in some way sorted or continuous around the points of interest. Okay, and in particular, a genetic algorithm is a guided random search algorithm that takes inspiration from biology, particularly from evolution, where we have this idea of natural selection, and that if you have some characteristic that makes you more likely to survive, say you're quicker at running away from tigers or something like this, and we have survival of the fittest, you're more likely to pass on your genes to the next generation, and those features will get propagated. So how do we apply that to a genetic algorithm then? So if we take the example of evolving a string, so not programs yet, just a regular text string. So say we want to evolve one containing the title of this talk. Okay, so what we're going to do first is we're going to generate some initial population of strings, maybe 100 of them, 1,000 of them, just completely random strings, all different lengths, different characters. We're then going to evaluate those and see how much they look like the target we're trying to get to. So this is where our analogy of evolution has somewhat completely gone out the window, because we now have an end goal in mind, and we're going to construct our fitness function such that we are steering this algorithm towards reaching that. Okay, so having done that, we're going to select which members of this population should survive and pass on their genes. So which initial strings looked the most like the target. Okay, and naively, we might just say, we're going to take the half with the best fitness score, just the top half, and throw the rest away. We're then going to cross them over, so this step is going to be analogous to you getting half your chromosomes from each parent. So again, a simple solution, we might just say, well, I'll take the first half of one string, second half of the other, and stick them together. There is then a mutation step, so in the same way as some genes get randomly mutated during reproduction to introduce new characteristics, we're going to pick a random character in this string and then just change it to a different one. Okay, so we've now got a population consisting half of the fittest individuals from the previous round and half of their sort of children, as it were. We want to now check, have we reached our target? If so, great, we can stop. If not, we're going to loop that round. Okay, and that's the general flow of it. So let's try and run that then. Okay, so what we're going to see when we run this is that for each generation, we're going to print out some statistics about sort of the fitness scores that we've got, and we're going to print out the best string that we've got in that generation, which to start with is probably going to be something that's about the right length, because in a collection of random strings, that'll be the best. Okay, so as this goes, we should see some features start to emerge, the spaces go in the right places, the characters get correct, and indeed we've got to the talk title. Okay, so that's all well and good for strings, but now say we want to evolve programs. So there are some extra challenges here. So whereas with string evolution, I could just dump some random characters into a string, and it's a valid string. It might not be very close to what I want, but it is a string. With program evolution, if I just put a load of random characters into a file, the odds that that's going to be a valid Python program, a valid C program, what have you, are pretty slim. There's lots of rules about syntax and things that we're going to need to conform to. So you might think, okay, well, I'll have some templates. Like this thing looks vaguely like a for block, and I'll have some blanks, and I can fill those in. And I'll have templates for if statements and that sort of thing, and I'll combine them like that. And fair enough, you will generate your initial population, will have lots of valid programs in, and that'll be fine. But when you come to cross those over and to mutate them, you'll very quickly get back to invalid stuff again. So you might say, okay, well, to make crossover easy, I'll have my own language, and it'll just have a load of symbols, and you'll be able to put them in any order you like. Okay, and that might work. The problem you're going to have there is that we want to be able to program arbitrary things in this language that code that we're evolving. We don't want to limit what we can create. So what we need is for the language to be something called Turing complete, and the idea, and the language that you kind of naively make may not be so. So what do I mean by something being Turing complete? Okay, so Alan Turing did a lot of work on the theory of computation, and in particular the idea of reprogrammable machines that could be used to compute arbitrary stuff. And so he came up with this concept of a Turing machine as a sort of model to think about this, to help him mathematically reason about them. And all it is it's an infinitely long piece of tape. It's divided up into a series of cells. You have like an arrow that points at the cell that you currently look at, and you can move that arrow backwards and forwards. And in each cell, you can put a symbol in there. You can read out the current symbol, or you can change the value of that symbol. That's all it is. It's a very simple device, but it can be shown mathematically that anything that is computable, and not everything is, there are certain things that are mathematically impossible to compute, but if it is computable, it can be computed on this device. Okay? And when we say a language is Turing complete, all we mean is that it can be used to simulate any single-taped Turing machine, aka anything that's computable, you can compute in that language. So it enables us to program whatever we like, basically. So those are our requirements then. We're looking for a language that's very syntactically simple and that is Turing complete. So at this point I thought, well, that probably already exists. Let's not reinvent the wheel. So like any good developer, I Googled it, came across this site, Corey Becker's site, primaryobjects.com. This is a great site. She's got lots of articles on there about machine learning. One of them was a project where she'd been working on pretty much exactly this problem, so evolving code rather than writing it. What is this language used? So it's got only 8 characters, and it's pretty much a model of a Turing machine. So in the interest of not getting myself thrown out of the conference for swearing repeatedly throughout the rest of the talk, I've left the name of it slightly as an exercise to the reader, but I'm sure you can guess. So the first 6 characters are pretty much just a Turing machine, so this is moving the pointer backwards and forwards, changing the value at the cell, reading it in, and reading it out, and putting a value in. The last 2 characters, the square braces, are where things get interesting. This is what gives us our control flow. So the ability to say, based on the value I've got here, I'm going to make a decision. I'm going to keep looping, or I'm going to break out of that loop. So that's what allows us, gives us language this power. So what does a program in BrainF look like? So this, for example, is Hello World. So your classic first program, just print Hello World to the screen. As you can see, this is a fairly esoteric language. You wouldn't really want to write anything complicated in it, particularly when you get past just printing output. It gets rapidly quite complicated keeping track of what you're doing. You certainly wouldn't want to try and debug or maintain any code written than this. But to a computer, this is just as intelligible as, say, a piece of Python code, a piece of C code. It's fine running this. From our point of view, we already know how to generate strings, we already know how to cross them over, mutate them, and this is just a string, so we can apply all the same techniques. So let's try then and evolve a program in this. I was going to do Hello World, but I realized there's probably not time in this talk for that to converge on a solution. So we're just going to go for a slightly abbreviated one. It's just going to say hi. Okay. What we're going to see is for each generation, we're going to print out the output of each program, and we're also going to print out the program string, the actual BrainF code itself, for the best individual in that generation. Okay. So we have some new issues to contend with here. So we now have the potential to have an invalid program. So while BrainF has very few syntactical requirements, you do need to match up those square braces. So if those aren't matched, the program's invalid. We also have the potential to time out, so we can have a valid program that gets stuck in an infinite loop. So we need some cutoff point after which we judge, yeah, this probably isn't going to finish, and class that as an error as well. We also, because real machines don't have infinite amount of memory, we have to use a finite length tape rather than the model's infinite one. So our program might go off the end of that memory, in which case, again, we need to notice that. So all of these cases we spot, and we give them a very low fitness score, so we try and weed them out so they're not selected to the future generations. The next thing to note is that we get quite close to the target output and then don't seem to get very much further. So why is that? So unlike the string evolution, where the thing we were evolving and the thing we were measuring its fitness of were one and the same, here we're measuring the fitness of the output, but we're actually evolving the program string. So while the output might be very close, it might require quite a big jump in the program code to get to where we want. So it might be stuck in a slightly awkward loop or require quite a big mutation. Okay, and so to try and help with that, we've increased the number of types of mutation we allow. So rather than just having replacement, you can now sort of have mutations that insert random characters or delete them. And in terms of the replacement one, rather than just being a single character that we might flip, we're kind of going to go over the whole program string and maybe change any of those. We also need to change our selection metric. So if we just selected the top half, that would be a bit too elitist. We'd be very narrowly driving towards something that looked like the output to start with, and sort of cutting off avenues that didn't look so promising originally, but would come back around. So what we want is some chance to include those individuals with lower fitness score, so that we can increase our chance of getting out of these local minimum we get stuck in. So what we're going to do is, rather than selecting the top half, we're going to have sort of like a roulette wheel spinner. So if you imagine like a pie chart where the size of each wedge is going to be bigger if this individual has a higher fitness score. And then we're going to spin it and sort of select ones. So lower fitness individuals may still be selected, but with a lower probability. And so hopefully we will then actually get to the solution. Running a random demo is a bit of fun on... Ooh, that's fun. A bit of fun on a presentation. One thing you will notice is that some of these programs are quite suboptimal, so you'll see lots of pluses in a row followed by lots of minuses. So clearly there's things that we could do to make that more efficient. So we have hi, so we have our program. This is good. So it's worth saying that this can be taken further. So Rebecca Seitz, she took this and she made evolved programs that generate the first few Fibonacci numbers, or that took user input and added those numbers up. So more interesting things can be done. I think it might also be quite interesting to, rather than evolving BrainF programs, to say take the abstract syntax tree of Python and try and evolve that and see if you get that to work. So I certainly did some stuff with function evolution, modeling those as trees, and that did work. So I think that could work. So, if you're interested, all the code for this talk is up on GitHub. I hope you found it interesting. I'd like to thank, again, Cambridge Medical Robotics for enabling me to be here and give you this talk. As I said, we are hiring, so if you too would like to work with knife-wielding robots, it does make you sound quite interesting at parties, and in all seriousness is very rewarding work, potential to save some lives. And we're interested in Python developers, software test engineers, if there are any embedded C developers in the room, or if you could do any of those, it'd be great. More than one, even better. But yeah.
All right, thank you very much, Emma. Do we have any questions?
Hey, thanks. So you're generating lots of programs and then running them. Is there any danger of this doing anything weird on your, I don't know, like on your computer, or I don't know what's included in this BrainF library in terms of APIs, what it can do on your system?
Yes, yeah, it can do arbitrary things, so it could potentially do anything. Yeah, that would be bad.
Any more questions?
Hi, thank you for your talk. So what I got from this is that you sort of evolve a search space and you set the software to find it. Now, in the high version, probably it wasn't very, very efficient, but like performance-wise, would you sort of go for this in order to make like also evolve programs or go further? I mean, that do you have proof that these genetic algorithms really are worth going deeper into that?
So I didn't quite hear that. Was that a question
have
about...
you actually tried it somewhere?
Was that a question about how you could make the performance better? I didn't quite hear.
No, it's like, do you have any actual sort of scenario where you have tried this and you got a better result than just writing code on your own?
Sorry, I still can't quite hear you. Have I tried it and
Shall
had
I
a better
speak louder?
result?
Do you have an actual scenario where you have used this, like a real life?
Oh, in real life? Probably not. It was mainly for sort of fun and interest's sake, educational value of trying it out. I guess if you could improve the performance so it worked better, then yeah, why not? Certainly if for some reason you wanted to write BrainF programs, I don't want to have to write those, and this can certainly write them quicker than I can. So for dealing with something like that, then yes, this would be better, but like kind of why would you do that normally? But I think it's certainly interesting, more from a sort of academic point of view of kind of what could you do if you push the boundaries of this rather than any practical applications right now.
Hi, great talk. Are you using generic algorithms for robotics development?
Am I using them for what?
Generic algorithms for robotics, yes.
Oh, okay. No, I'm not using them at work at the moment. This was just a side project. Yeah, I think when it comes to surgical robots, we probably want them to be slightly more deterministic, but yeah.
Thank you. Have you ever experimented with evolving the syntax tree of the program instead of the text representation? Maybe this is much more efficient, I don't know.
Yeah, so I haven't tried that. It's one of the questions that came up when I gave this talk at PyCon UK last year, and certainly I think that would be a really interesting thing to do with this. So we did look at function evolution, so evolving polynomial functions, which model as trees in kind of a similar way that you would for abstract syntax tree, and that did work for evolving them, so I think you could definitely do it. I'm quite tempted to try.
Any more questions?
Hi. Is there any specific reason that you use genetic algorithm instead of any other optimization techniques?
Not particularly. So we were just studying a range of different topics in machine learning, and this happened to be the one that I was doing at the time, which is why I use this. Not for an instance saying this is necessarily the most optimal way of doing this, but it was just interesting. Really.
All right, if there are no more questions. Oh.
Yeah. Hey, why wouldn't you use genetic algorithms or any kind of algorithms for the robots? Because, I mean, we have self-driving cars that kind of go in that direction. I mean, I understand that you want deterministic behavior, but I guess you could achieve good results.
So why would you use them in general? I think if they're a useful search algorithm, so if you have, like I said, data that is in some way sorted so that you can tell from looking in one area if the thing next to it might be quite useful, it can be a more efficient way to search a large space. I don't think you would, I'm not aware anyway of any applications for self-driving cars, but I think it's more kind of searching large amounts of data that it might come to play.
Okay, right. It's lunchtime, everybody. Thank you very much.
PyCharm's tips and tricks. Please welcome Dmitry Trofimov, who's the leader of PyCharm's team.
Hi, my name is Dmitry. The first question maybe is not expected, like who of you swam in the sea today in the morning? Yeah, I did also. That is amazing. Yesterday I didn't do that because I was lazy, wanted to sleep more, but my colleagues persuaded me to go today. I went and that was so amazing. Do that tomorrow if you survive a party or anything, but coffee helps after, but it is worth it, definitely.
If you want to swim, you have to relation of power.
Wow, thank you. Postgres. So, the second question, who of you already use PyCharm? Almost everybody. That is so nice. So I will try to focus on tips that are maybe a bit more advanced and unexpected. And my goal for today is like everybody knows at least one new thing in PyCharm. Also, I did some kind of that talk a couple of months ago, 3 maybe months ago, at PyCon Italy. Anybody listen to that talk at PyCon Italy or? Okay, one person. There won't be many new things. There will be maybe three, four things that I added, but mostly it is almost the same talk. But we'll see. So the first thing that I want to show is the thing that I didn't mention. In Florence is the new kind of product of JetBrains that ties together all other products that's called Toolbox app. Anybody knows about that? Who knows? Nobody knows. Great. So I'm done. So easy. Toolbox app is an application that allows you to manage easily the tools and the projects. So you have here 2 tabs. That's your projects, and that's your JetBrains IDEs. And you can update, you can roll back updates, you can install new versions, and it's very easy to track what versions do you have, and it's very easy to launch things from here. For example, you have, for different projects, you can have different configurations. For some projects, you can use EAPs. By the way, how do you use EAPs, early access builds? Great. Please come to our booth and we'll give you a t-shirt. Because the people who use APs, first of all, they get new features earlier, and then the most important then can help us actually to make those features much better because they submit their feedback earlier. And it's much easier to fix stuff before you release the feature, because after you can move on to other things. And so I encourage you to try APs. They are pretty usable. So let's start. Here we have Toolbox, and we can launch from here PyCharm. So it's PyCharm Community, PyCharm Professional. In theory, I could just press and it will open, but I already have it opened. That's PyCharm, you know it, and for today's presentation I will use the project called VMProf. VMProf is the profiler that was developed by PyPy guys, that initially was Maciej Fialkowski and Anthony Cooney, who are there at the conference. You can meet them, and they came up with this profiler like at EuroPython 3 years ago, I think, and it is very nice. Sample and profile it. Also, it has it's open source, and it has UI at vmprof.com, which is written in Django, and that's why we'll use it as our sample project, because it's not very big and not very small. It's very good to show stuff. It's on GitHub. So what we do in PyCharm to open projects, we go and we can check out directly from version control. So we just press GitHub and clone, but that won't work because internet here is so slow, and I'll open already cloned project instead. So what do we do normally when we open a project? So most of the time, first we want to learn what that project is, and we want to read the code. And in PyCharm, you can, of course, do that file by file, but the easiest way to do that is use search. And in PyCharm, for example, you know that it's a Django project, so you can press Command-Shift-N, and you can type URLs, and you can navigate directly to this file. And you see that PyCharm shows you the list of the files very fast. And why is it so fast? Actually, it is very fast because we have indexes, and this speed of access to all the files and classes is not free, and you pay for it by indexing. And people complain about indexing. Why do you have indexing in the when PyCharm starts? And so indexing is payment for speed ups later, so you can access your code very fast because of indexing. So indexing will stay forever. We work constantly on improving the performance, so this cost, this payment decreases every year, every month. We try to optimize them, but still indexing is a good thing. So yeah, and let's return to our urls.py. How do you navigate in PyCharm? You can actually go to you can read the code, yes, as in all editors, but also what you can do, you can press Command and click and go to all the functions. No, it's not, it doesn't work. Why it doesn't work? Yeah, I forgot to tell you an important thing. It doesn't work because interpreter is not configured. And PyCharm tells us about that, and we can press this link, and you see that interpreter is not configured, and what we do first. Normally, when we open a project, we create a virtual environment. So in PyCharm, there is a button for that. You press this option, and you type vmprof server, something like that. And you select Python 3. You select Python 3.6, this one. And PyCharm creates a virtual environment for you. And after that, you can use it. But what we have now is PyCharm actually tells us that dependencies are not installed. How PyCharm knows about that? There is a file called requirements.txt in the project. And actually, if PyCharm found it automatically, if PyCharm doesn't find it, you can go manually and set up it here. So you see that requirements.txt is selected. And actually, that's the way to change your environment, because sometimes you have different setups for testing, for production, and you can select here different requirements, and you just press this button, and here comes one very important and not very obvious tip. So when we open this window, it's OS X default file chooser. Yeah. Yeah, that's a very good answer, because setup.py is a Python file. We cannot execute it, and you can specify dependencies in a lot of ways in setup.py, and require. No, we use requirements.txt because it's like machine-readable format, and it's like I advise you, if you didn't listen to, advise you to listen to the keynote of Armin Ronnecher on the first day. He talked on this topic. So the requirements.txt is a direction in the right, it's a movement in the right direction in Python. So you have your dependencies in a clear, specified in a clear formal way, and it's machine readable, it's easy to understand, and setup.py, you can, like, it's Python file. You can introspect that, but that won't work in all cases. So we don't encourage you to write dependencies there. Sorry? We don't support it yet. It's not standard. It's some experiments, as far as I know. Does anybody have a question about this? No, so let's proceed. I wanted to show, like, are there here OS X users who uses Mac OS X? Yeah, this tip is for you. This is like, if you want to choose a file in PyCharm and you see this screen, is the default file chooser, and it's not very convenient. It doesn't, it's just bad. So what you can do in PyCharm, you can actually use the feature called registry. It's a set of hidden settings, more like system settings. And you can open them, and you can see there a lot of settings, and one of them is Mac file chooser native, and we disable that. And after that, we return to our file chooser, and you have here much nicer UI. You can navigate to your project root, to your home directory, and you have auto-completion here, and it's so nicer. But we'll leave it as it is, so we select production txt, and you see PyCharm now understands your project when the interpreter is selected. It highlights this as red, and you can install requirements. We won't do that again because internet won't allow us to do that. Instead, we take already configured virtual environment. Yeah, and after we configure that, we can navigate to all our classes and modules, and we can do whatever we want with that. And there are several actions. I showed already go to file. It's Command Shift N. By the way, you can see this hint in the bottom of the screen. It highlights the shortcuts. There are several others. For example, Command N is go to class, so you can type class and it will show it. You can show actions in the IDE, so as I did for registry. And there is a general action called search everywhere. It's double shift, and you can type whatever you want, and it will show both classes and files, and it shows actions as well. So there are a lot of ways to navigate through your code. Actually, navigation, that knows everybody. But there is one more thing. For example, you have a lot of models. Like let's go to some Django. That's Django. There is one more, by the way. It's called find symbol. We can go to models. Like you can introspect models going one by one using go to definition. That's cool, but there is a better way, which is very not obvious. In PyCharm Professional, that feature is available in Professional Edition as well as Django support in general. You can see the diagram. You can press show diagram pop-up, and there are several diagrams that you can open. And that is, for example, Django models diagram. So if you have some unknown Django project, you can just open it in a visual way and see how it looks. That is much faster than go from file to file. And of course, that is much faster than just read the code in text editor. Yeah, another way how you can learn about your code is structure. There is a tool window for that. It's called structure window, and it shows you the top-level definitions in your file. And also there is a structure, file structure, which you can invoke with a shortcut. And here you can also navigate very easily. It shows you top-level definitions with, for classes, it shows also fields. So it can be very handy. When you are somewhere in the code, deep in the code, and you want to see where you are, what is the context outside of the file, you want to go fast to your file structure, there is a shortcut for that. It's very handy. I use it all the time. It's Alt F1, and you can navigate to the project view, Power Center, and you see where you are. And there is one more thing, you can go even further. There is a setting which is not on by default, and not very many people know about that. You can enable auto scroll from source here in this tree. You enable that, and then wherever you are, the file tree is updated and synchronized with your editor. So the active tab in the editor is shown as it's selected in the file tree. Speaking about the file tree, project file tree, as all other trees in PyCharm and all other IDEs, are searchable. And that's also not what not everybody knows. For example, if you have a focus in the tree, you can just start typing. You can type apps, and you see that the focus moved to the apps.py. And also after that, you can press up and down. For example, we press down and we iterate through the highlighted items. That is very handy, and that works for all the trees. For example, the same thing works in the debugger. When you have your variables, you can start typing there. If you need to, if you're looking for some variable or even for some value, you can start typing and it will navigate in the variables view in the debugger. Right, so yeah, sometimes people say that like, I said the word tabs, and that remind me that like sometimes people say that PyCharm is like a bit complicated in comparison with text editors. And when you start to ask why, people say that there are a lot of things, like you have tool windows, you have tabs, you have like it's bars, buttons, and actually what you can do in PyCharm and what a lot of people do is you just can remove that all, and I will show you step by step how you do that. For example, nobody needs those buttons, especially when you use shortcuts. You might be using those to run things and these to select run configuration, but you can do that with shortcuts. So you just press this. No, that's not what I missed. This toolbar, and it's gone, right? So here you have rather convenient navigation bar. You can select here directories, and you can go to the files. But actually, it duplicates what you have here. So you can remove it as well. Navigation bar, you press here, and it's gone. But if you need that, you can invoke it by the shortcut, which I don't remember. No, it's it's a bit hard. It's on OS X, but you have a shortcut, and you can do everything you want from here. You can navigate, and even you can create files from here, just in the editor. So I think this is much better than having the navigation bar on the top. What we do next? Of course, we don't need all those tools, like data view. We don't use it for now, and we can, like, pressing here, we can remove that. Tabs. Tabs are informative, but some people say that they eat too much space, and we can configure that as well. So we go type tabs here, and we have here the main setting is placement. And placement can be top, can be left, can be bottom, can be right, and like it can be none. So we move tabs to def null, and we don't have tabs. And you see here we have like minimized version of PyCharm that actually looks like Sublime Text or any editor. That doesn't look complicated. It looks very light. And we can go even further, and we can enter distraction-free mode, the special mode that actually automatically removes everything. So yeah, it looks like that. It removes the project window, and it removes the left gutter. But I don't like it myself because it removes gutter, and you don't see breakpoints here when you debug it. I don't know whether you see it here, but breakpoints highlighted as pink line, and it's not very visible, it's not very convenient for me. So I don't use destruction-free mode. I just remove everything by myself, and if you don't need project, you can collapse it, and you can go there only when you need that. So how do you navigate between your files when you don't have tabs, when everything is collapsed? One, the most frequent used action is recent files. So it's Command E, and here from this pop-up window you can navigate to the recent files, and also you can navigate to the tool windows. For example, if you switch between two files, you can just do like that. You press Command E, and you go to rotors, and you press Command E, you go to models, and you don't need to touch your mouse and move it to the first tab, then edit something, then touch it again, move to the second tab. So it's much faster. Another thing is you can actually go back and forth with a shortcut. So it's, there is a shortcut Command Alt left and Command Alt right. And for example, you went somewhere, you edited something, and you want to return back. So what is back is a different story, but you know that you want to go back, like in browser, so you can press Alt Command left, and you actually go back. But it's it tracks not only files, but also positions in files. So if you edited someplace in one big file and you go to another place, it will return you inside one file as well. But it's also very handy. As I told you, go to file is a perfect way to navigate. So you don't need tabs. So you just, if you remember the names, you just type and you go. Right, so, yeah, okay, so what do we do? I want to check whether I forgot something to show you. Do you have any questions, by the way? About navigation, or maybe you know some tip that I forgot to show. By the way, I don't know all the IntelliJ platform. I developed PyCharm for 7 years already. But IntelliJ platform has so many features, and all the features it has, first of all, a lot of features I don't know at all. I don't know that they exist, and I learn all the time something new. And I think I learn slower than they are being developed. And there are some features that I know that exist, but I don't use them. And I think that happens always with new tools, with new features, that people like they know that something exists, but they don't have time to invest to learn something, and they think, okay, I will do the old way because I'm quite efficient doing the old way. But it happened with me a lot of times with IntelliJ. Then I learned some new way, some new feature, and you spend some time learning the new way, and then you understand that the old way was just so cumbersome, so time-consuming, and you start doing something new, and it's very efficient. So I encourage you to learn. Not especially, of course, PyCharm, because you already use PyCharm, but it applies to all the tools, and just learn new things. Yeah, that's advice for myself.
One question.
Yeah.
Do you have a summary of all these shortcuts in your talk?
Summary of shortcuts. Yeah, we have actually, if you go to help, you have here key map reference. Oops. Yeah, that was something I printed for my daughter. And you have here the nice PDF that contains all the shortcut for your operation system. Also, at the conferences we have printed key maps, but I don't think we have now nothing left. Yeah, very nice thing. If you, yeah, it's so good. I will show you it. If you still use tabs, I know it's not the right preferences. If you still use tabs, let's enable them. You have several tabs, right? And you want to close them. in PyCharm, you can easily close everything by shift-click. So you don't need to target this little cross. So you just press shift and you click, shift and click, and you can close everything by that. Shift-click, close everything. It's a very, very nice tip. It saves time. You don't need to hunt the pixels. Yeah, all right. Let's write some code. So we read through the project. We know something about that, about the project, and now we want to add some lines of code. And we start doing test-driven development. We start by adding some tests. So we go and write something, and you see that it's not a good example here. You see that PyCharm completes all the syntax that actually you don't need to type. That is obvious PyCharm types for you. But this makes the life more difficult for some people, because PyCharm completed itself and it closed the brace and added the semicolon. But what do you do now from that? How do you proceed? Does anybody know how do you proceed from this point? The fastest way how to start writing the implementation of the test function. Yes? Yes. It's shift-enter. Actually, not everybody knows that. So you can press down, but then you go to the beginning of the line, or you can go left, enter. That works, of course, but shift-enter much faster. And we type something like that, self. And from here, you can actually invoke documentation, pressing Ctrl-J. You can view documentation just from the completion. So, for example, you take an object and you want to invoke a method, and you want to read documentation. You just can do that from here. You can do that and read, and you actually can start exploring the library from here. It's like a browser. It's very handy. Yeah, and you also what you can do. No. Okay, no. I won't show that. You can actually what you can do is I don't remember the shortcut, unfortunately. You can show the definition as well. So right from here, for example, if you don't have documentation, if you use some of your library that doesn't have a documentation, you can show definition right from here, from the completion. And you can see how it is implemented to know what to execute. That is very handy as well. So it can save a lot of time. Right, but we know what we want to execute. So we execute that. But we don't know what to enter, and PyCharm shows you the arguments. If it doesn't show you, you can invoke parameter info with command P. And yeah, and you see that PyCharm also highlights you if argument is missing, but I guess you know all that. So we write our test like that, and we can run it, right? It's PyTest. We just press run. Fails. Yeah, now we want to fix it and we want to work with some code. How do we do that? There are two hints that might be useful. The first one, you write test, you write code, you write test, you write code. What you can do, you can split the screen and to have unsplit, split vertically. You can split the screen, and from here you can go. And for example, you can edit your code, you can edit your test, and work you know that, I guess. And another thing that I bet you don't know is you don't need actually to run your tests all the time. You don't need to click this button. You don't need to press the shortcut. You can actually enable the thing that's called toggle auto test. You see the tooltip, and you press this button, and after you change something, PyCharm automatically restarts tests, and you see now they pass so it also can save time. So it runs all your tests for you. Okay. You probably see this green stripe on the left. That's the version control integration. But first, I close that. That's version control integration, and yes, PyCharm has a lot of supports a lot of version control systems, and we use Git ourselves in JetBrains, so I would say that we have pretty decent Git support. And what you can do, you can create new branches, new test, something like that. You can create new branch, and you can commit. And of course, you can do all that with a shortcut. You can write new test, edit, test. And you commit that. I bet you know that all. What I want to show is not very obvious. Who uses cherry pick working with Git? Yeah, there is a very good tip that I'll show. First of all, you probably know that there is a version control tool window which shows you all version file, also shows git log. And from git log, you can do the following. For example, you can switch to the master branch. And here you can see all other branches. And we select new test, the branch that we just created. And there is a button which is called highlight non-picked commits. Basically, it compares two branches. It compares the branch you selected here with your current branch which you are working on. And you press that, and it grays out all the commits that are absent from your current branch. And it's so convenient when you want to see what was added to the branch and absent in another branch and move some commits. It's very convenient. And from here, you just select those. This is highlighted as bold because it my commits. It highlights all my commits as bold. By the way, I think I can disable that. But you see that those are gray. This is not. And from here, I can press this button, cherry pick, and it will cherry pick right from here. You don't need touch terminal at all. It's very cool. My favorite feature in version control. No, that is unfortunately not supported, but it will. There is a long-standing feature request, and for some reason, our developers of version control integration, they were against this feature for some, I don't know why, but now they're convinced and they're working on that. All right. What you can do, actually, you can easily roll back changes, but you've seen that. For example, you have some change here, and you can roll back it from here, and you can see the difference right in place. You don't need to see the difference. For all file. Yeah, about the differences, there is one feature which people don't know, but it's very cool. Unfortunately, I don't know how to demonstrate it very well. Is compare files, compare directory. You can compare everything. For example, you can select a folder and press option command D or compare with, and you can select, I don't know, you can select another folder. And it will come, of course, that's not very, because those are two different folders, but I think you see the idea that it compares file by file, and it can actually, if there are pictures, it shows you the pictures. So this is the best way I know to compare two different contents in file system which are slightly different, and you want to see what is different and maybe merge something to move some changes around. That's the best way I know. Right, so yeah, a lot of features, yeah, I even don't know. So the main thing that is so useful when you edit code is code inspections. Inspections are some checks that are executed on your file, and they highlight some errors or the ways to optimize your code. And here we have, they are marked at the right scroll bar, and you can see them right here on the scroll bar. You can move slowly the mouse, and you can see, this is called lens, you can see all the warnings right in the editor. And yeah, what we see is that here in this project there are a lot of violations of PEP 8, and we fix it with, how do we fix it? What's the name of the action? Anybody knows? Refactoring, not exactly. Yeah, reformat code. There are two ways of doing something with the code. One is refactoring, and one is, it's located here. It's some complex operations on your code. When you rename something, when you move something, when you need to check, when you do something with code, some code object, and you need to check that all the references to it also updated, it's refactoring. When you're working with code as with text, that is like code operations, and there are a lot of them as well, and one of them is reformat code. It's Command-Alt-L, and you see that PyCharm makes the code compatible with PEP 8. Also, we see that here we have unused imports, and we have an action for that. It's called optimize imports. Yeah, now it looks much better. And if we scroll down, what is here? We have here some typos checked. If we want, we can add those words to the dictionary. We see here that methods are not implemented. Yeah, I think it's nothing interesting to fix. But actually, yeah, we touched keyboard twice, and we did a lot. We did, as Paul Everett called it yesterday at PyCharm debugging tutorial, like the janitor work that the IDE actually does. I like this analogy. It's like the IDE does for you the janitor work. You don't need to touch your imports. You don't need to insert lines and move your methods. You just press some shortcuts. In a second, you have the very good code style. Right. Yeah, and of course, that all works for JavaScript. For example, if we go to JavaScript file, we see here that those lines are not terminated with semicolon. It's a question whether we should or not, but if we don't want, we can disable this exception. If we want, we can just terminate, and we can terminate statement, we can terminate the file, but what we can do also, and that we can do for all inspections, we can select the folder or project, and we can call the action called inspection by name, run inspection by name, and terminated statement. And we can do that for directory, for example. And you see that PyCharm finds 494 unterminated statements, and actually we can fix that right from here. We can press Alt-Enter and terminate all statements, so in all project, all statements will be terminated. And that is valid for all inspections, so you can apply those quick fixes. And if you don't know about that, quick fix is some transformation of your code that you can invoke manually. Normally, it is invoked by Alt-Enter. So in a lot of places in your code, you can just press Alt-Enter and see what PyCharm offers. PyCharm can offer you to make the code better, sometimes. Yeah, but we won't do that to save some time. Right, so yeah, we have Django project. Maybe we should try to, who does Django, by the way? Like a third, or maybe 25%. For Django, of course, you know that there are run configurations to run Django tests and Django server. Let's see that. This is the, everybody knows what is run configuration. Who doesn't know what is run configuration? Okay, a run configuration is the way how to run something. So there are predefined types of run configurations, and in many cases they are created automatically. When they are not, you can create them by pressing and selecting. For example, there are run configurations to debug JavaScript in browsers, to run some JavaScript tools, for Python tests, for a lot of stuff. And of course, there are run configurations for Django, and the one that we'll try is Django server. And let's run it. Just press this green triangle, and let's go here. And it doesn't work because we don't have database. And when we don't have database, what should we do? We should run migrate task. How do we do that in PyCharm? Does anybody know? Any ideas how to, the best way to run the Django commands, managed by commands? So yeah, that's right, Django. Actually, you can, if you don't know, you just search Django managed by, run managed by task, right? And there is a special console for running managed by commands. And how it is better than terminal? It's better because it shows you help, and it shows you expected arguments. So if you don't know what command does, still you can use this console, and you don't go to Django documentation, which is great, but right here you can, the console reminds you what it expects. So we run migrate. And also what we need to do is we want to populate this with data, and for that we start, we run vmprov from the terminal. And as you see, PyCharm has terminal, and the nice, how it is better than any external terminal. One thing is, for example, here you have virtual environment already activated. So you just open the terminal, and you have already activated virtual environment for the project you are using now. No, okay, let's type that. So that's how we run from the terminal vmprov profiler, and it uploads the snapshot to our local instance that we launched. And now, I guess, after the restart, we have the data, yes. And we can look here that our website works. But also, for example, we want to see the actual data. So we want to go inside the database to see what data is located in the database. How do we do that in PyCharm? The best way, like we go to settings .py. No, it's not settings. Yeah, so let me check that. Manage .py. Web app settings. No, doesn't find it for some reason. Because it's not file. Yeah, it's not file. All right. And how to, by the way, how to find it if it's not file? So we type. Yeah, that's the way. That's not. I would say that is a failure of our UX. That's why I didn't find it, but also you can count it as a tip. For example, if you look for a folder and go navigate to file, pop up, you need to type the slash and then. I know that it's strange. That's how it works now. I hope we'll change that. So yeah, what we do, I already forgot what I wanted to do. We go to databases and we see that it's SQLite, right? SQLite, we navigate here. And from here, we press as data source. Okay. Okay. No. And you see that it's added to the data sources, and you can actually see the tables and CPU profile. You can see our entry that we just created from the terminal. And also you have SQL console right in the PyCharm, and you can write from, and here you have also code completion, vmprof, CPU profile. Right, and you have here history of your queries, and so can be pretty convenient way to work with databases. And based on this functionality, actually, JetBrains has a separate product called DataGrip. It doesn't support any programming languages. It's focused on the databases, and it is included in the PyCharm Professional Edition. Okay, so we have some time. Yeah, and I want to show you the two things, right? In the end, like I showed two things. There are, as you know, there are two problems in software engineering, like cache invalidations and naming things. I would like to show you how you solve that in PyCharm. For cache invalidations, and that counts as a first tip that I want to show. Sometimes PyCharm can highlight some imports as red for no particular reason, and that is the first problem, cache invalidations. It means that we could not invalidate caches, and there is an action called invalidate caches and restart. So you might try that, but it happens very rarely. But sometimes it is still useful, because I have on Stack Overflow, I once answered that question. PyCharm highlights something as red. What do? I answered like invalidate caches, and I still get like karma for that answer. So that's why I'm talking about it. That might be helpful. But that's rare. It's a rare case. Normally it works. The second thing is naming things, right? So you want to write some code, and you like some few lines of Python code, and you don't want to create a project, you don't want to create a file. What do you do? Do you know what is the way to do it in PyCharm? Except console. You have Python console, yeah, but it's for one-liners. If you want to write several lines, what do you do? Scratch, exactly. So you look for Scratch, new Scratch buffer, or you, yeah, it's a shortcut for that, and you select the language, Python, and you just write your code, and I have here some code. And you can run Scratch files as they are normal files, and you can do actually like everything. It doesn't do everything. Okay, we need to print. And that is postfix completion that I just shown you. And you can debug from here. And this is another thing that you might not be using right now is debugger in PyCharm, which I claim much better than PDB. Yeah, and yeah, f-strings. Let's try f-strings. So it works. And duplicate line, remove line. It's just showing some shortcuts for actions. Yeah, and this code is Python code, right? It's f-strings in Python 3.6. the syntax is highlighted, and you see there is a code completion. But that's not unique only for f-strings. Actually, that universal machinery inside IntelliJ products is called language injection, and I will show you how to use it. It can be used for all languages. For example, you can write something like regex, or you can write something, I don't know, and inject language or reference, regex, and it's highlighted. Or you can SQL. From table, it's already detected. It's injected it on its own, or it can be JSON. EuroPython 2017 application. Inject JSON. Yeah, of course. Let me try. I don't remember the shortcuts around with. No. Surround. That's a good question, by the way. Does anybody know how to do that the best way? Huh? No, it will. Okay, let's search for that. Surround, selection, type and quote on brace. Yeah. I learned something new today. That's great. Yeah, and braces as well, no? Yeah, and braces as well, yeah. Cool, that's cool. So yeah, do we have any time, or how much time do we have? No, we don't have. It's 2 minutes. Okay, then we are done. Thank you very much. I tried to show as much as I could.
Thank you, Dimitri. Are there any more questions? Okay.
Hi there. Thanks for the presentation. I was wondering if it's possible to make PyCharm consume coverage reports that were generated externally, because I know you can run with coverage from within PyCharm, but I have the coverage report already from my continuous integration for Jenkins or Travis, and I want PyCharm just to use those ones rather than generate its own.
Yeah, in PyCharm you can generate the external coverage report, but you want to use the already generated coverage report to highlight in the editor.
Yes, I want the externally generated coverage to appear in the PyCharm Gata.
There is, for coverage, there is action to open, but I guess that's for internal like serialization format, so it won't work for coverage.py. And I know that we have feature requests for that, and we at some point we fix that. It's counted as a super word. Yeah.
Okay, another question?
My question is based on a comparison between like suggested code completions in Sublime and in PyCharm. So in PyCharm it seems to rely on knowledge about local variables and what types they are, you know, what methods they contain and so on. Whereas Sublime, it offers things that you've just typed before anywhere, like within the file, which I found very useful as well. Is it possible to achieve that in PyCharm? Do you understand what I mean, or?
Sorry, I couldn't
Sorry,
understand.
I need to slow down, perhaps. So, in Sublime, suggested code completions, it will, like, if you start typing something, the first few characters of something you've typed before anywhere within that file, it will suggest it as a completion. This doesn't happen in PyCharm. Like, suggested completions are based on, say, knowledge of like the local variables within a function, what types they are, like what methods they might contain. Do you understand?
Yeah. If I can understand correctly the question, you're saying that in Sublime, when you start typing, it suggests you auto-completion for the words that you used already.
Exactly.
PyCharm does
Is
the
it possible
same.
to do this in PyCharm?
PyCharm does the same, but what PyCharm does actually is it understands the semantics of your code, and it provides you not only with just random tokens across the file, but it tries to guess what you want to type. And if you start typing here, it first suggests you variables and functions, but also you can, for example, here we'll type something. Let's try the name. I think that this thing will be, suggested.
It's not in the namespace, the global namespace, so it doesn't suggest it. Is that correct?
Complete. Actually, there are several types of completion in PyCharm. So when you type, there is a pop-up completion that that understands the scope, and it's very fast and shows what in the scope. There is also completion. Let me find an action for that. Completion. Class name completion. That actually is a bit slower, but that goes out of the scope, and it proposes you all the name that it has in the indexes. So it's not only for classes, it's for modules and classes. So that's what probably will help you, if I understand correctly. So you type things, they are not in, PyCharm understands the context, it doesn't provide it because those names are not in the context. They are in the outer scope. Then you just invoke this class-based class completion, control alt space, and it goes up to the index and goes up in the scope in some sense, and it provides you with all the names. But also it has semantics. It won't provide all the words. I don't know. I could not invoke that, but I'm sure that we have token-based completion. I will think about that. Thank you for the question.
Okay, thank you.
Any other questions?
Here, I think.
Hi. I like PyCharm's linting, but other people in my company use PyLint, and the interaction between those two it's very hard to synchronize them. Is there a good way of doing that, or will there be?
Could you please repeat?
Sorry, too fast.
Yeah.
I like the linting that PyCharm has and how it displays the linting errors. But other people in my company use PyLint. And
but what is PyDev?
Sorry?
What they use, you said.
Other people use PyLint.
I don't hear the name, unfortunately. I don't know. Maybe something like this. Maybe
sorry.
I need to stand here.
Not Flake 8, but PyLint.
Wow.
Sorry.
Okay, PyLint, yeah.
So obviously you can run PyLint from inside PyCharm, but it doesn't integrate the output it gives. It doesn't display it on the file. Is there any way of doing that, or might there be?
You want to run PyLint from PyCharm, right?
Yeah, I'd like to be able to use.
Yeah, you can do that in some sense by using external tools. Right,
but then the output from PyLint is just is not in line.
It will show the output in the tool window. If you want it to be shown as a PEP8, for example, in the editor, it's not implemented yet, but we know about that and we want to fix that. Maybe this year, I think.
Cool.
Okay, and unfortunately we are out of time, so if you want to learn more about PyCharm, please visit Dimitri at PyCharm booth. Thank you, Dimitri.
Thank you very much.
Hello. So next up, PyPy, abstractions for free. Please give a warm welcome to Antonio Cunni.
So, hello everybody, thank you for coming. First of all, can you hear me? Is the volume fine? Okay, good. So in this talk I will talk about PyPy and the PyPyJIT in particular. First, a few words about me. I've been a PyPy core developer for more than 10 years now. I'm also the author of some other open source projects like PDB++, VMProf, and others. You can find me on Twitter. And before I forget, I will show you some demo code in this presentation. You can find the source code at this link, so if you want to try it by yourself. So let's start talking about PyPy. Usually when we are at conferences and talk with people about PyPy, the general question is, how fast is it? And actually the answer is, it depends. There is no single answer to this question, because it really depends on the kind of code you are running, and as we will see, it will also depend on how this code is written. If you go to speed.pypy.org, you can see the benchmarks we run every night, and there is also this nice graph which is summarized. As you see, we compute that on average we are seven times faster than CPython, but of course this number doesn't mean anything. It really depends on your code. And as I will show in this presentation, the cool thing is that because of the way the JIT works, it is able to remove a lot of the overhead of abstractions in your code, which means that the better the code you write, the greater is the speed up against CPython. So what does it mean to write good code? Well, first of all, it needs to be correct and it works, yes. And then it's nice to have code which is readable, which is easy to maintain, which has a nice API. If you are writing a library, designing the API is very important, because this is how the user will use your library, and if the API is easy to use, well, your library is much better than the alternative. And of course, it would be nice if our code is fast, and in particular, it would be nice if by writing nice code which is readable and maintainable and etc., we don't impact the speed of the code. Usually, one way of writing good code is to make a good use of abstractions. Like, for example, it's something that we all do when writing code. We try to factor out common pieces of logic into functions. Then we group common pieces of data and behaviors into classes. We use inheritance to share behavior and etc. And yes, this makes the code better and more readable and etc. But sometimes this style of writing code has a cost, especially on CPython, as we will see briefly. In the following, I will show you a demo, and I will show you various ways to write the very same piece of logic, and we will compare the performance of CPython and PyPy in the various versions of the code. The demo is about some image processing. We are running a Sobel filter on some video or stream from a webcam with the result to compute some edge detection of the image. This is just a copy and paste from Wikipedia. I am not really a computer vision guy, so I don't really know how it works. I just copied and pasted it from somewhere else, basically. So how do we represent an image? In this demo, we start by representing an image in a very simple way. An image consists of a variable which contains the width, the height of the image, and an array, which is our data. We are talking about a grayscale image, so each pixel is represented by 1 byte from 0 to 255. And so yes, we have this linear array, and we can index a single pixel at position x and y by doing this simple calculation. So we go to Wikipedia, we see what is the math behind it. We just write this simple loop in which we do everything in line, basically. So you can see that here we have our image, which consists of three variables. We create the output image, and for each pixel, we do the calculation. You can see that, for example, to address each pixel, I do here the computation manually every time. And well, basically, this works. I can show you the demo, like this is the program running on PyPy, and you see that it kind of fast, it works on real time. You see the number of FPS, it's a bit slow because it's the frame rate of my webcam. If you use a video file, it's much faster. For comparison, let's try with CPython. Yes. It's not even too bad. I mean, more than 1 frame per second, yes. From now on, I will avoid showing you the real-time image. I have also a quick program to benchmark the various versions of the code. So this is CPython, which does almost 5 frames per second, and this is PyPy, which does more than 270. So yes, this is very good. PyPy is some large number faster than CPython. Here there are the histograms, but as you see, the y-axis is at a different scale, because I'll say, well, the CPython would be too little to be seen. But yes, I mean, the version, this works, it's fine, but it's really bad code, because, for example, here we have the logic for computing the index for a single pixel, which is repeated again and again, and it's very bad. So what we do, we start to make it a bit nicer, and we write some functions to get a pixel and to set a pixel. So our code becomes a bit nicer. So you see that we can call this function to get the pixel. What happens if we run it? Let's try on CPython. Yes. It's computing only 10 frames on CPython, because if computed all the frames of the video file, it would take forever. So you see, it's like half the speed of before. Let's try on PyPy. Ooh, almost the same speed as before. Actually, the number really varies a lot, because, of course, it is a laptop with hyper-threading and the temperature of the CPU, so take it with a grain of salt. But yes, in general, basically, this version is the same speed as before. And yes, so we start see. We wrote code which is nicer and better, and PyPy is already faster than CPython, much faster than CPython than before. So we do more. We start to represent an image by using a real class, an actual instance. So we have this class, we save the width and the height and the data array, and we have this get item and set item special methods, which computes the actual index in the array for us. So now it becomes much nicer to write. I don't have a slide here, but no, I think it's version 2. Yes. You can see here that we can index directly the pixel inside the image. And as you can guess, we run it on CPython. And it's again slower than before. And we run it on PyPy, and guess what? Well, still the same speed. So you start to see a pattern here, because we introduce more and more layers of abstractions, and on every layer of abstraction introduce an overhead on CPython, and no overhead at all on PyPy. And this is because, as we will see later, the JIT has logic to remove this kind of overhead. And so, as I say, the better the code we write, the faster it becomes. So now we want to make it even fancier, and we start to represent a point inside the image, like with a class, and we can add a point to another, so that we can compute offsets for the point. And also, we want to abstract the notion of how to iterate over the image into a nice method, because, for example, in this version of the code, we run the filter, the kernel of the computation on all pixels of the image apart the border, because we don't have the neighbor pixel to consider. And but there are various possibilities and other ways to handle the edge cases. So we didn't want to put them in the for loops. Like we see in the for loop here, we have this range from 1 to h-1, which basically means to avoid the border, but it's much nicer to put it in a method. And as we see here, basically we return an iterator which iterates over all the pixels of the image by computing them using iterators.product. And so basically we can start to write our code in a slightly different way. For example, here you see that we iterate over all the pixels. We are only one loop instead of the two nested loops of before. And to compute the neighbors, we really can use a nicer syntax, because we can just say take the point which is 1 pixel right and 1 pixel to the bottom, and etc. And yes, I show you. On CPython, this starts to become very, very slow. Now I can even drink some water while we wait. Maybe I should drink the whole bottle. I don't know what's happening. Yes. So remember, we started on CPython to almost 5 frames per second, and now it's like 10 times slower or something. And guess what? Oops, sorry. Version 3. Yes. Oh, no, this is too slow. Yes. I think this is my laptop, which is getting hotter, but yes. No, actually, there is a bit of penalty here. If you run it a lot of times, you see that you get a slightly smaller percentage of number of FPS. Probably the JIT introduces a bit of overhead, but it's really tiny compared to the overhead which is introduced by CPython. I didn't look at the exact code produced by the JIT to see where this fraction of the performance is lost, but it might be that, for example, that here iterators.product actually creates a new object which needs to be collected by the GC, so we had a bit of pressure or something like this. I don't know, but really it's negligible in comparing it to CPython. So we want to go even fancier. Is this code big enough to be read? I hope so. So basically, what we did so far is to do a manual computation, we have this matrix, which is shown here with two matrices. And the idea of a filter is that for each pixel in the image, we want to compute it, to compute the multiplication of this matrix. And here, basically, we do it manually, but it would be much nicer to abstract also this computation, to write it in a saner way. So here we have our class, which represents the kernel, and when we give it the matrix, like this is a copy and paste from the Wikipedia page, and when we call this object passing an image and a point, it computes the multiplication of the matrix for the point. And yes, I mean, this started the code now starts to be really nicer than before, because, for example, if we want to try another filter or something else, we can just edit the values in the matrix and be happy. And so let's try it again on CPython. Yes, now I really can. Yes, basically, I mean, the talk is scheduled to last 1 hour, but most of the time is spent in waiting for CPython to do its things. Is it ready yet? Yes. Even slower, not much slower than before. So now, guess what happens with PyPy? Any guess? Nope. Now it's much slower, like 10 times slower than before. I mean, it's still faster. I mean, it's still much faster than CPython. If you start from this version of the code, you run it on CPython and PyPy, you see that it's 76 times faster, and you're happy, and you go to conferences to say that PyPy is really nice and it works. But actually, I mean, here we are running much slower than we could, because I mean, the title of the talk is Abstraction for Free. This is not free at all. So yes, we concluded PyPy sucks and I'm a liar and please go home. Well, of course not. Yes, basically, I will show you later why this happens, but the point is that the PyPyJIT works by computing loops, detecting loops and compiling assembly version of these loops. But here, normally, when we have this kind of code, we have one loop, which is the for loop, and the JIT sees a list of operations, so it emits JIT code, assembly code for it, and this is run in a linear way, and it's, well, the CPU can do it very fast. But here, we start to have a lot of nested loops, and basically, it means that if you look at the generated code, when you are in the iterating over all the pixel, then you do the equivalent of a function call to the other loop which has been compiled by the JIT. And this kind of operation is slowish on PyPy. As long as you stay in one loop, it's very fast. If you jump between loops, it's still fast. I mean, it's still 70 times faster than CPython, but it's not as fast as if you stay in a loop. So one possibility to solve this issue is to unroll manually the loop. So basically here you see that we have this function which creates a kernel function from the matrix I pass, and I'm using this PyPy tools module which I wrote, and it's available on PyPy. and it doesn't nothing special. It's just a nice wrapper to generate code on the fly. And you see I'm generating a function which I call apply, which takes an image and a point, and I manually unroll the two nested loops here, and for each combination of j and I accumulate the value of the computation in this special variable, which I then return. And then with this nice library I wrote, you can ask it to compile. Compiling this code is really done by running exec on the string, nothing fancy. And then I return it. Basically, if we pass this kernel, JX, it generates this kind of code, which you see is very, very similar to the code I showed you earlier, which I wrote manually, but now it's much nicer because the API of my library still looks like this. I create a kernel, and it automatically gives me the nice fast function. So let's try it again. I don't even try on CPython because you can guess now that it's utterly slow. And yes, we are fast again. Again here now I'm getting less FPS because probably it's really getting hotter. But trust me, earlier I got a higher result. So this is the final graph, and we see that PyPy is again 400 times faster. I mean 400 times faster than CPython, I repeat. So what did we learn so far is that on CPython, every time you try to be nicer, well, you pay a cost. Because Python is a dynamic language, and every time you call a function, it has to do a dictionary lookup in the global namespace, and every time you call a method on the class, it has to look up the method in the dictionary of the class, or of the instance if it has, and every time you multiply two numbers, it has to create a temporary value and this kind of overhead. On PyPy, we saw that the abstractions are almost free. Yes, there are a bit of overhead from the first to the last version, but it's not much, and it's something that you can pay quite easily, but if what you gain is much nicer code. So in the second part of this talk, I want to give you a very rough idea of how PyPy is able to do this kind of magic and optimization. So we will see some example of code and see what the JIT produces. But I warn you, this is not a detailed explanation, and this is not even a completely correct explanation. I try to simplify things because I think it's easier to understand. If you are interested in a deeper and more detailed explanation, and even a more correct one, I gave a talk at some EuroPython ago. I think it was 2013 or something, and you can look at the slides or the video of the talk and look at it. So let's start from a very simple piece of code. We have this function which computes the sum of n numbers, and it's just a while loop. When you run it on PyPy, what happens is that at some point PyPy recognizes that we are running a loop, so we are running the same code again and again, and after a certain number of iterations, the JIT kicks in and compiles the code of this loop. And what produces is something like this. This is pseudocode, but I think you should understand more or less what's going on. The first thing to notice is that we are compiling only the loop. You see that there is no code for the 2 lines before the loop and for the line after the loop. We are running only the loop, and the loops in PyPy are always infinite loops. And the way you exit the loop is by failing a guard. What is a guard? In this pseudocode, I wrote the guard as assert. Basically, in the JIT code, we insert some checks here and there to ensure that the preconditions we assumed are still true. So, for example, if we pass an integer to compute, we have total and I and n, which are all integer variables, and we can produce a specialized version for this code, which is able to do an integer addition here. If we pass a float, well, the assembly code is no longer the same, because at the CPU level, we have different instructions for adding to floats or to integers. So the JIT will have to generate another one. And here you see that the guard is that we are checking that the variable we passed is actually an integer. And also, because of the semantics of Python, every time we do an addition of 2 integers, we need to check for overflow, because in this case, we need to switch to longs. I'm talking about Python 2.7 here. So you see that every time we do this integer addition, we also need to check for overflow. This is also a guard. So what happens is that in the normal case, you have a very fast loop which sums integers. These are really low-level integers. Like if you write a program in C, it's not like a fancy structure which is malloced in memory. It's really an int, a variable, which is stored in a CPU register. And as long as there is no overflow, everything goes fast. Also, you see that the condition of the loop has been turned into another guard here. So it means that at some point, this guard will fail, and this is how we exit the loop. And then there is a lot of complicated code in PyPy which switch back from the JITted code to the old interpreted one. So let's see what happens when things are more complicated. So suppose you have an if inside your loop, and in this case, every other iteration you do one operation, and every other iteration you do the other operation. What happens is that at some point we are on the loop, and after a certain number of iterations, the JIT kicks in and compile a version of the loop. But when the JIT kicks in, it sees only the iteration which is being executed now. So we only see one path through the code, not the other. So for example, in this particular case, we only saw the then branch of the if, but not the else. You see that here in the code which has been generated by the JIT, it's more or less like the one before, but we are asserting that we are in this branch of the code. The other is not considered at all. So what happens is that the next time you do the iteration, this guard will fail, and you get out of the JITted code. And there is special logic that checks that if a guard is failing very often, then probably means that it's worth compiling it again, as well. So what happens is that after a certain number of guard failures, the JIT compiles what we call a bridge, and basically it attaches another piece of assembly code to the code which was already in memory. We really go in memory and change the operation, the CPU instruction from being a jump to the JIT fallback code to a jump to the newly compiled code. So in this pseudocode, what happens is that we have 2 two different bridges. One is the main loop, and the other is the newly compiled bridge. But you see that one important thing is that we never do a merge after. So, for example, this instruction, which is done after the if, here is replicated both in the main loop and in the bridge. And this basically is one of the reasons why on PyPy you need to take warm-up into account when you are measuring your performance, because if the program runs for not enough time, you spend too much time compiling the various loops and bridges. After a while, not much. I mean, you see that on my example, a couple of seconds were more than enough for warming up. Everything has been stabilized usually, and all the hot path of the code has been compiled by the JIT, and you're happy. So go back to our example. If you remember, the first version, improved version of the code was the one which put the logic to compute the index inside the array into functions. And we saw that PyPy did not suffer from performance. This is done because for the way the JIT is written, inlining happens automatically. So here we have the same function as before, but this time the addition is done inside this function. And what happens is that the JIT doesn't care, and they just see that inside the function we do the addition, and so we put the low-level instruction directly here. But well, Python is a dynamic language, and if I just give you this code and ask you to execute it, well, you cannot be sure that fn is always the same, because it might be that someone monkey-paged my module and fn is something different. Or it might even be that I manually change the under code attribute of the function and make it executing something completely different. And so the function is still the same, but the behavior is different. And there are a lot of crazy things that can happen in Python. And this is one of the reasons why it's so hard to optimize. And the PyPy approach is to insert a lot of guards for each of these conditions. And so, for example, here, we check that the globals dictionary, which is the dictionary where the fn lives, is still at the same version as before. The version is just an internal number that we use to keep track of the state of the dictionary. Every time we modify the dictionary, we increment the version. So if nobody touched the dictionary of a module, which doesn't happen often after the initialization and importing, well, this guard will never fail, and it will work fast. And the same thing for the under code of the function. But also note that we are smart enough that we put all these guards outside the loop, because the JIT has a knowledge of what's going on, and it knows that by executing these few operations, we cannot change the globals and we cannot change the fn code attribute. So basically, we move the guards out of the loop, which means that when you enter it, it does a couple of quick checks at the beginning, and then in the inner loop, which is where the time is spent, there are no guards, or few of them. And now you start to see why the version in which we had the two different loops compiled was slower, because we need to do these checks again and again every time we enter a compiled loop function. The same for classes. So for example, here we have the class point, which has two attributes, and I can compute the distance from the center by calling this function from the math module. And suppose I have a list of points, I want to compute the total distance. And here I insert more and more guards, because in Python a lot of things can change, really. So here, to make sure that the code inside p.distance is really this one, I need to check that the global dictionary didn't change, that the dictionary of the math module didn't change, that the dictionary of the point class didn't change, and that this function still points to the same global as before, because it's doing a global lookup of the math symbol and other things. So basically, after all these guards, we are sure that the code here inside is this one. So you see that, again, in the loop, we can insert and inline the call to this function which is written in C, or in EuroPython in the case of PyPy, but yes. So I think that now you start to see a pattern. Basically, every time you have some dynamic behavior of Python which makes it hard to optimize, well, PyPy tries to reduce the dynamicity by putting guards and hoping that the situation doesn't change, which is very often it's true, because, for example, modifying the fn, the code attribute of a function never happens. But if it does, PyPy is still correct. It means that the guard fails, so we cannot use the JITed code. We are slow, but we are correct, which is important. And finally, one of the most important optimization of the JIT is the one about virtuals, and this is where you really win a lot. Because, for example, suppose here I rewrote it in a different way, and at each iteration of the loop, I create a new point object, and then I compute the distance. I mean, I could call math.hypot directly, but in this case, for show you this optimization, I had to do this. What happens on CPython? It means that at every iteration of the loop, I create the new object, so I do a call to malloc, and then I call the init, and I set the x variable to I, the y variable to I plus 1. Then I call the distance, so I do another method lookup, and etc. And you see why you are paying a lot of performance. What happens in PyPy is that PyPy recognizes that here, at every loop, we are creating this point object, we are calling a method on it, but we are immediately destroying it. It never escapes the loop. So the JIT is smart enough to explode the structure of the point object into two local variables. So instead of creating an object in memory and storing x and y in memory, it stores them, for example, in some CPU register. So here you see that instead of having an object p and a p.x field, we just have a px local variable, and the same for the py. And so now we can, again, inline the call to p.distance. Note that we have less guards than before, because now we know that, that p is of type point, because we just created it. Well, we didn't create it because we virtualized, but from the abstract point of view, it's this kind of class. So we can even reduce the number of guards. And basically, that's it. And that's why PyPy can be so fast. And basically, by applying this kind of optimization, you can see that in all the version of the code of the demo I showed you, we removed all the overhead of the abstraction to get more or less the same performance as before. It's possible that the bit of slowdown you saw, it's because of these extra guards, for example. You pay a bit for the dynamicity of Python, but not much. And there is another thing I wanted to show you, and it's related to this guard I showed you before, because, for example, when we do an inlined call, well, basically the JIT has to check that this code object is is still the same than it has seen before. But let's go here. This is the version 5. Here we are creating dynamically a new function. So it means that we are creating a new code object again and again. And in this particular case, PyPy is fast because this function is created at the global level. So we create only once, and the JIT always sees the very same. But if I modify the code, actually I didn't try this, and I hope that my theory is correct. But I'm quite sure it is. So if we move this call from outside to inside, something like this, then it means that every time the JIT will see a new code object, so it cannot apply the same optimization as before, and so probably it will be very slow. Yes. So this is an important thing to know because I have seen it in real life code, which maybe creates classes inside functions or things like this. And in CPython, this does not change much, but from the point of view of PyPy, it changes a lot, because even if it's the same function, it has a different identity, so the JIT cannot be sure that the behavior is the same, and it has to recompile the same code again and again. So basically, that's it. There are more PyPy events here at EuroPython. Tomorrow we will run the PyPy help desk, so you can come and ask us questions. On Friday there is a talk about the general status of PyPy, which will be done by Armin, who is here. And I don't know what he's talking about in particular, but yes, if you are interested in PyPy, you might be interested in coming. Or you could just stop us here during the conference and ask us questions, because, well, I'm happy to answer all the questions you have if you want. So if you have questions now,
first of all, let's thank our speaker for the presentation.
Thank you.
And we have time for questions.
Thank you for your talk. Wanted to ask, why do you need to check the version number? Is it not enough just to check that the code pointer is still the same?
Sorry, could you speak slower because I didn't understand?
Why is it not enough to check that the code pointer stayed the same? Why do you also need to check the version number of the globals?
Why is it not enough to check the version number?
Why is it not enough to check that the code pointer stayed the same?
Because the dictionary might change. Maybe the same dictionary, but the content of the dictionary has changed. Or I didn't understand the question.
Yeah, it was slide 31, if I remember correctly. But it would still have the same code pointer, because we're also checking the code pointer.
Sorry. Yes. Both need to be checked, because you can change, you can hack your Python interpreter by changing what the name fn refers to, but you can also keep the same name fn but changing what fn.code refers to in Python. So we need to check both.
I don't know if this answers your question, but let's try. So now foo is free, but if I can do this, So this is kind of dynamicity of Python which gets in the way when you want to optimize. But I see. Well, for example, you could have the two functions with the same code object but different globals. So it's easier to check for the function object. But, or maybe you have a global lookup of a constant, and then you want to check for, well, that the constant is still the same, basically.
Hello, thank you for the presentation. I have a question about the benchmarks you showed earlier. I think it's kind of an unfair comparison because most CPython developers would not represent an image as a list of lists or import array. Same developer in CPython would go straight to NumPy for this. So I was wondering if you had benchmarks or comparisons against NumPy, and how does PyPy compare in this case?
Yeah, I didn't try. I mean, yes, this was not the point of the talk. Yeah, I know that if you write CPython, it probably can be much faster by using NumPy or some specialized library. But sometimes you just need to write your Python code, and which is not in some library, so it's useful to know that what you pay and what you don't pay. It was just an easy example to show, basically.
Hey, going back to slide 31, I think it was. You're assuming essentially that you're running single-threaded there. How do you cope with the world changing asynchronously? So somebody could, in another thread, change one of the built-ins. I mean, that would be an insane thing to do.
What happens with threads?
So you've got your loop. Do you periodically check that the state of the world hasn't changed, or?
I don't know. Armin, do you know?
So yes, what occurs if you have a small enough loop, then the loop can be written in such a way that you know that it's not going to release the GIL. So as long as GIL is not released, then you use the fast path. And for the case where you call something and maybe the GIL has been released, then after the call returns, you need to do the checks again.
Hi. When you went from version 4 to version 5, that sort of optimization, how do we, if we run our own code on PyPy or something, and how do we find out that that's the sort of optimization we should be looking for? How difficult is it to find out?
Sorry, the question is how did I find what?
So if we run our own code on the PyPy, and it is kind of not very fast for some reason, for a similar reason, how do we find out on our own code that that's the sort of area we have to explore to speed
well, actually,
up?
I knew because I know how it works. Yes, what happens in real life is that you have this program and you see that it's slow or not fast enough. So what I usually do is first to profile, like for example using vmprof to see where we spend most of the code. Then there is a tool to look at the code produced by the JIT, and if you know what are the optimization which you expect to be done, and you see that one optimization is not applied, it doesn't apply, then you have a hint of what's going on. For example, a lot of time happens that you expect an object to be virtual, like this kind of things. When I write code with PyPy in mind, often I know that the object I'm creating is temporary, so it will be virtualized. But sometimes I look at the trace and I see that it's not, because maybe it's passed to some function which was not compiled by the JIT or other things, and this kills the performance. So if you rewrite the code by removing the line of code which forces the object, it becomes virtual again, and it's much faster. Yes, unfortunately, there is no easy to use tool to detect these scenarios. you have to know basically what are the optimization that you expect, and if you see that some is not applied, well, then you try to understand why. And that's why this kind of talk is useful, I think, because you start to get an idea of what you can expect and cannot expect from the JIT, basically. Did I answer your question?
One more in back.
Are there any plans to remove the GIL from PyPy?
Sorry, was it a question?
Are there any plans to remove the GIL from PyPy?
The author of PyPy?
Plans to remove the GIL from PyPy, the global interpreter lock.
Yes? Okay, then I understood completely different question, yes. Yes, there is an ongoing branch, but I don't know much about it, and probably you should come to the Friday talk to to know more.
Hello. You had some guards about asserting that an integer doesn't overflow, but I don't think you can guarantee this unless you can solve the halting problem. So if the guard fails during the loop, does it just revert to plain Python code, or what happens then?
So the question is, what happens when a guard fails?
Yes, inside the loop there was a assert that the integer doesn't overflow.
Yes, basically.
But you can't know this ahead of time, so.
Well, basically what happens is that we exit the jitter code, and we have a special piece of code which tries to recover the state of the computation, and we go back to the interpreter. So failing a guard is expensive, but most of the guard never fails, basically, or fails very rarely.
Hey, thanks for your talk. In your abstract, you mentioned that you're going to compare how using PyPy compares to using other popular optimization methods like Python. Can you shed some light on that?
Yes, actually, I'm sorry about this because when I wrote the talk proposal, it was months ago, and then when I prepared the talk, I forgot I wrote about this, this stuff, and so I didn't insert it in the talk. And, but yes, I have a real-world experience of it because I wrote a library which is CapMPy, which is about parsing CapMProto in Python. CapMProto is a binary protocol. And the goal of this library is to be fast both on CPython and PyPy. And it was hard because, as you saw, the two interpreters have very different performance characteristics. So what I ended up doing was to write pure Python code, which was very fast on PyPy, but then I annotated it externally with Cython annotations. So basically on CPython, I compile the pure Python code into Cython code, which is a bit faster. And on PyPy, I just run the pure Python code, which is much better. In general, when you are running code on PyPy, if you have to choose whether to run pure Python code or the same code written in C, pure Python is faster because the JIT has more knowledge about what's going on. And there have been a couple of places in which I could not find a version of the code which was fast on both implementation, so I had to write two different versions, one for PyPy and one for CPython, but yes.
Hey, so in this example, it's pretty small.
Okay.
How well does it work on sort of real-life complex code when a lot of, let's say, in each trace, a lot of levels are traversed, a lot of functions are called, like 10 functions deep? Do you have a rule of thumb how far it works?
I don't have a precise answer, of course, because it really depends on the kind of code. But I have seen real-life code in which PyPy is 10 times faster than CPython. But sometimes it happens that you start from an existing piece of code, and you try PyPy and it's lower, and then you look at the traces, for example, this is what I did at some point, and I saw that something that I expected it to be optimized was not, and by tweaking a couple of lines of code, I managed the code to make the code 10 times faster or something like this. In this particular case I'm talking about, the problem was that there was a dictionary in which the user mixed the Unicode and string keys, and which is fine in Python, but in PyPy we have a special optimization that if you have a dictionary whose keys are only strings or only Unicode, you get a specialized implementation. But if you mix them, you get the non-specialized lower implementation. So in this particular case, by switching to using an homogeneous type for the key, I got it much faster. But yes, I don't have any magic rule to make a generic piece of code faster.
Hi, what developments can we expect for the JIT in the future? Can you make it, for example, more intelligent to handle the example you showed at the end, where you moved the code around to handle that better?
Sorry, the question is, what do I expect for the JIT in
yeah, what new developments you can implement there, and what we can expect in the future?
Sorry, I didn't understand. Maybe yes.
Okay, try again. What developments can we expect for the JIT in the future? Can you make it more intelligent so that it handles your last example, for example, better?
Yes, I think that nowadays the JIT is kind of mature, so we already did all the easy things to do to make it faster, but there are always new ideas on how to make a particular case faster and optimizing one particular behavior or something. I don't think we have any magic idea in mind right now, but we are keeping adding new features basically. And it's very nice because every time you add a new optimization, you unlock other optimization, because I didn't show it, but you can see it in my other deeper talk. The optimization of the JIT they really work well together, because sometimes an optimization, like you make something virtual, then produces some code which is handled very well by another optimization. So at the end, a lot of operations are removed or simplified. So maybe if we add some new optimization to remove a particular piece of overhead, then by doing this, the other optimization will start to work much better than before, and you get a real speed up. But yes, I don't know how to answer this question more precisely, basically.
And if we don't have any other questions, I think we can thank our speaker once again. Also, the lightning talks are going to start in this room at 5. So is there any way to save the meta information of previous runs so that startups?
No, this is something that we thought about, but it's almost impossible, because what we actually generate is some machine code which contains actual addresses in memory. So when I say that there is a guard about the code object, it really contains if the pointer.
The meta information is used like the counts